Somewhere in the galaxy, there may be a world where the sun rises so slowly that an entire civilization could grow old beneath a single dawn. Imagine standing there for the very first time. The horizon is dark, cold, almost completely still. Above you, the stars never move quickly. Nights stretch across decades. Oceans sleep beneath sheets of dim silver light. Mountains cast shadows that remain frozen in place for generations. And then, after years of darkness, something begins to change. Not suddenly, not dramatically, just a faint glow touching the edge of the world. A sunrise so slow that no human being could ever watch it fully unfold within a single lifetime. Children might be born beneath the first pale colors of morning and grow old before the sun finally climbs into the sky. It sounds impossible, but in the universe, worlds like this may truly exist. Astronomers have discovered planets orbiting incredibly slowly around faint red stars, distant suns that burn with only a fraction of the brightness of our own. Some of these planets may rotate so gradually that one single day could last years, or even centuries. On Earth, sunrise feels ordinary, predictable. Every 24 hours, light returns. But elsewhere in the cosmos, time itself behaves differently. There may be planets where dawn is not an event, but an era. And in the silence of space, these worlds drift endlessly around their stars, wrapped in darkness so deep that the first appearance of sunlight might feel less like morning, and more like the awakening of an entire world. Scientists believe many of these planets may be tidally locked. That means one side always faces the star, while the other remains trapped in eternal night. But between those extremes lies something extraordinary. A narrow twilight region, a thin band around the planet where the sun never fully rises and never completely disappears. An endless sunset. Imagine living there. The sky would glow in permanent shades of orange, crimson, and deep violet. Frozen winds might move slowly across endless plains of black rock and ice. Above the horizon, the star would hang motionless, larger than our sun appears from Earth, bathing the landscape in dim reddish light. No mornings, no evenings, no changing seasons, just stillness. Some scientists think these twilight zones could actually be among the most stable places for life in the universe. Not too hot, not too cold. A cosmic balance suspended between fire and darkness. And perhaps that is one of the strangest things about the universe. The places that seem most alien may also be the places where life quietly learns to survive. Far from Earth, beyond the reach of our telescopes and imagination, entire ecosystems may already exist beneath skies humans have never seen. Oceans could ripple beneath dim red sunlight. Thin clouds might drift across frozen valleys. Strange forms of rain could fall slowly through dense atmospheres, rich with unfamiliar chemistry. And all of it unfolding in near silence, because space itself is quiet, truly quiet. There is no sound traveling between the stars, no wind rushing through the vacuum, no thunder echoing across the galaxies. Even the most violent cosmic events happen in silence. Supernovas explode without noise. Black holes collide without roar. Entire planets freeze in darkness without a single cry. And perhaps that is why these distant worlds feel so mysterious. The universe does not announce its wonders loudly. It whispers them slowly through light, gravity, and time. Some of the quietest places in existence may be planets drifting far from crowded galaxies, worlds orbiting old and peaceful stars in the outer edges of the Milky Way. Out there, the night skies may be darker than anything we can imagine. No nearby suns, no glowing nebulae, just endless fields of distant stars scattered across eternal blackness. A person standing on such a world might feel as though the universe itself had stopped moving. But it never does. Even in silence, planets continue turning, stars continue burning, galaxies continue drifting through the dark. Right now, somewhere unimaginably far away, a slow sunrise may already be happening on a world no human eye has ever seen. A frozen ocean may be glowing faintly beneath the first light in centuries. Mountains may be casting shadows that move only inches in an entire lifetime. And perhaps, beneath those ancient skies, something alive is watching the dawn arrive, one silent moment at a time. When we look up at the night sky from Earth, it is easy to imagine the universe as cold and empty. But the deeper we explore, the stranger it becomes. The cosmos is not just filled with stars, it is filled with places, quiet places, sleeping places. Worlds where time moves differently, where light behaves differently, where the rhythm of existence itself slows into something almost dreamlike. And maybe that is why space feels so calming to us. Because beyond all the chaos of Earth, beyond noise, cities, and human urgency, the universe continues patiently, slowly, silently. A reminder that not everything needs to rush, that somewhere out there beneath another sky, a sunrise is still unfolding, one tiny fraction of light at a time. Far beyond the warmth of familiar suns, there may be worlds where oceans still exist, even though the surface has frozen into endless night. Not oceans beneath blue skies, not waves touched by sunlight, but hidden seas buried beneath miles of ancient black ice. In the silence of deep space, these frozen planets drift quietly around dim stars or wander alone between them. From afar, they might appear lifeless. Their surfaces are pale, motionless, locked beneath temperatures so cold that even the atmosphere may have turned to frost. And yet, beneath that frozen shell, something may still be moving. Water, slowly, quietly, endlessly. There are moons in our own solar system that hint such worlds may already exist. Beneath the icy crust of Europa and Enceladus, scientists believe vast oceans may be hidden under frozen layers thick enough to swallow mountains. These seas are never touched by sunlight. They exist in total darkness, warmed not by a sun above, but by heat deep inside the world itself. Now imagine planets far larger than these moons. Entire worlds wrapped in ice, entire oceans hidden below them. Some of these planets may orbit so far from their stars that daylight is little more than a dim glow, weaker than twilight on Earth. Others may have been thrown completely out of their solar systems, becoming rogue planets drifting through interstellar space alone. And still, their oceans may survive. Deep underground, pressure changes everything. Thick layers of ice trap heat beneath them, like a giant thermal blanket. Radioactive elements inside the planet slowly release warmth over billions of years. In some worlds, tidal forces stretch and squeeze the interior, generating friction that melts hidden water far below the frozen crust. So, while the surface above remains colder than Antarctica could ever become, an ocean quietly waits underneath. Dark, silent, unseen. If you stood on one of these frozen planets, the landscape might feel endless and empty. Black ice plains could stretch beyond the horizon beneath a sky with no sunrise at all. The stars above would appear painfully sharp in the freezing darkness. No wind might blow, no rain would fall. Every sound would vanish into the cold. But beneath your feet, miles below, there could be an entire ocean slowly moving through the dark. Currents may drift through underwater caverns larger than continents. Warm vents on the ocean floor might release minerals into the water exactly the way hydrothermal vents do on Earth. Around those vents, chemistry could become strangely active, and that raises one of the most haunting questions in astronomy. Could life survive there? On Earth, life exists in places we once believed impossible. Tiny organisms live near volcanic vents at the bottom of our oceans without sunlight. Some survive beneath Antarctic ice. Others exist inside rocks deep underground where no light has ever reached. Life, it seems, does not always need sunshine. Sometimes it only needs warmth, water, and time. These hidden oceans may have all three. Imagine creatures evolving in eternal darkness for millions or even billions of years. No eyes would be needed beneath the ice. Perhaps they would sense heat instead of light. Maybe entire ecosystems drift silently around underwater vents while the frozen world above remains completely unaware. The strangest part is that such places may actually be common throughout the galaxy. Many stars in the universe are small red dwarfs, dim stars that provide very little warmth. Around them, icy worlds may outnumber warm Earth-like planets. Some systems may contain frozen ocean planets orbiting quietly at enormous distances where sunlight barely reaches at all. Others may not orbit stars anymore. Rogue planets are among the loneliest objects in existence. Ejected from their solar systems long ago, they wander through interstellar darkness without a sun to guide them. At first glance, they sound completely dead. But scientists believe some rogue planets could still hide underground oceans beneath thick frozen crusts. Even without sunlight, internal heat may linger for unimaginable lengths of time. Their oceans could remain liquid while the surface above drifts through absolute night. A planet without a star, an ocean without light, a world still alive beneath the cold. It almost sounds impossible, and yet the universe continues to surprise us. Some astronomers believe these hidden oceans may actually be safer for life than many surface planets. Without direct exposure to solar flares, asteroid impacts, or radiation from nearby stars, underground seas are protected beneath enormous shields of ice. Life there could remain stable for billions of years without ever seeing the sky. If civilizations somehow evolved in those oceans, they might never know stars even exist. Imagine living beneath miles of ice your entire history. Your world would be water, darkness, pressure, and distant geothermal light from below. The universe above would remain hidden forever, separated by an impossible ceiling of frozen black ice. Perhaps somewhere out there, intelligent life already lives this way. Entire civilizations swimming beneath frozen worlds, never seeing sunlight, never knowing galaxies fill the sky above them. And while these ideas sound like science fiction, the evidence for subsurface oceans continues to grow stronger every year. Telescopes now search distant exoplanets for signs of ice-covered surfaces, strange heat signatures, and clues hidden in faint reflected light. Future missions may one day scan the chemistry of these frozen worlds directly. We may discover methane, salts, or organic molecules trapped beneath alien ice, tiny clues whispering that something moves in the darkness below. Not all life may bloom beneath warm suns and blue skies. Some of it may survive in silence, hidden beneath frozen shells at the edge of eternity. And maybe there's something strangely peaceful about that thought, that even in the coldest corners of the cosmos, where sunlight never reaches and the surface appears completely dead, oceans may still drift quietly in the dark, waiting, breathing, enduring. Perhaps the universe is far less empty than it seems. And tonight, as you rest here beneath the familiar sky of Earth, somewhere unimaginably far away, beneath miles of silent black ice, an unseen ocean may still be moving softly through the dark. Somewhere beyond the warmth of every familiar sun, there are planets that no longer belong to any star at all. They move through the galaxy alone, silent and unseen, wandering through endless darkness like forgotten travelers with no destination left to reach. These are the rogue planets, worlds that were once part of solar systems, once circling glowing stars beneath young skies before gravity turned against them. Long ago, many of these planets may have formed peacefully inside swirling disks of dust and gas. They may have had neighboring worlds, distant moons, and warm sunlight touching their atmospheres. But planetary systems are not always stable places. Giant planets pull at one another. Young stars shift. Orbits stretch and twist over millions of years until eventually something breaks. And when it does, one world is often cast away forever. A single gravitational encounter can fling an entire planet into interstellar space like a stone thrown into an endless ocean. No explosion, no warning, just a slow drifting departure into the cold. The planet keeps moving long after the star disappears behind it. And somewhere out there tonight, countless worlds are still wandering. Astronomers believe rogue planets may actually be incredibly common. Some estimates suggest there could be billions of them drifting through the Milky Way alone. Perhaps even more rogue planets than stars themselves. But finding them is extremely difficult. Most planets are discovered because they orbit stars. We detect tiny dips in starlight or subtle gravitational wobbles. Rogue planets offer none of those clues. They travel through darkness with no bright sun beside them. Invisible worlds crossing invisible distances. And yet, every now and then, we catch a glimpse. Sometimes astronomers observe a strange gravitational lensing event, where a dark object briefly bends the light of a star far behind it. Other times, infrared telescopes detect faint heat signatures drifting alone through space, tiny whispers of warmth in an ocean of black. Proof that these lonely worlds are real. Some rogue planets may be enormous gas giants larger than Jupiter, still glowing faintly from the heat of their violent formation. Others may be small rocky planets like Earth, frozen solid beneath endless ice. And some might be stranger still. Scientists believe that certain rogue planets could retain heat deep inside their cores for billions of years. Radioactive decay beneath the crust might keep hidden oceans liquid far below the frozen surface. Imagine that for a moment. An entire ocean concealed beneath miles of ancient black ice. No sunrise, no sunset, no sky at all. Only darkness above and warm, silent water below. Even without a star, a planet may not be completely dead. On Earth, life exists in some of the darkest environments imaginable. Deep beneath the oceans, near hydrothermal vents where sunlight never reaches, entire ecosystems survive using heat and chemistry alone. And because of that, some scientists wonder something extraordinary. Could rogue planets also harbor life? Not forests or civilizations beneath open skies, but simple organisms hidden deep below the surface. Tiny forms of life surviving quietly in oceans warmed from within, while the planet drifts endlessly between the stars. If such life exists, it would never see sunlight. It would never know what a star looks like. Its entire universe would be darkness, pressure, and the distant warmth of a hidden planetary core. And somehow, that idea makes the galaxy feel even larger, because it suggests life may not need sunlight as much as we once believed. Perhaps warmth, time, and stability are enough. Perhaps the universe is filled with hidden oceans quietly breathing in the dark. The skies above rogue planets would be unlike anything we can truly imagine. Without a nearby sun, there would be no blue atmosphere glowing overhead, no daylight, no golden horizon. Only stars, thousands upon thousands of them. The Milky Way itself would stretch across the sky with breathtaking clarity, untouched by sunlight or atmospheric haze. Distant galaxies might appear brighter. Nebulae could drift like pale ghosts across the heavens. For anyone standing there, space would no longer feel far away. It would feel immediate, endless, terrifyingly beautiful. And yet these worlds continue drifting in complete silence. Some rogue planets may travel alone forever, never approaching another star again. Others could eventually pass near distant solar systems after millions or even billions of years wandering through interstellar space. There is even a tiny possibility that rogue planets occasionally get captured by new stars, becoming adopted worlds in entirely different systems from the ones where they were born. A planet could spend billions of years in darkness, only to someday see sunlight again. Imagine the first dawn after an eternity of night. Astronomers have already discovered a few candidate rogue planets inside star-forming regions, drifting freely without visible parent stars. Some appear surprisingly young, still glowing softly in infrared light from their formation. They are cosmic orphans, planets without homes. And perhaps the saddest part is this: many rogue planets were likely never meant to be alone. Their exile was not part of some grand design. It was simply the outcome of gravity doing what gravity always does: pulling, scattering, reshaping. The universe can be gentle, but it can also be indifferent. And still, these wandering worlds endure. Even in darkness, they continue moving. Even without sunlight, they continue existing. There is something strangely comforting about that. A reminder that not every journey requires a destination. Some worlds simply drift through the cosmos, carrying their stories in silence. And maybe, somewhere tonight, one of those forgotten planets is gliding beneath the distant glow of the Milky Way, wrapped in frozen clouds, holding hidden oceans beneath its ice, moving slowly through the endless dark, while no one watches. A lonely world with no sunrise, no sunset, only time. And if stories about forgotten worlds help your mind slow down tonight, you can subscribe and continue drifting through the universe with us. Far beyond the calm blue skies of Earth, there are planets where storms do not last for hours or days, but for centuries. Tempests so vast they could swallow entire worlds. Winds so violent they circle a planet faster than sound itself. Lightning storms that illuminate clouds stretching across millions of miles of darkness. These are the giant storm worlds of the universe. And compared to them, even the most powerful hurricanes on Earth would seem small and fragile. In our own solar system, we already know of one famous example. On the surface of Jupiter, a gigantic storm called the Great Red Spot has been raging for at least 350 years. A vortex so enormous that multiple Earths could fit inside it side by side. And yet, even Jupiter may only offer us a small glimpse of what truly exists elsewhere in the galaxy. Many exoplanets discovered beyond our solar system are far larger than Jupiter. Some are massive gas giants orbiting close to their stars, heated to extreme temperatures where their atmospheres boil and churn continuously. Others drift in colder outer systems where storms move more slowly, but grow to unimaginable scales over centuries. On these worlds, weather is not gentle. It is planetary violence unfolding endlessly beneath alien skies. Imagine standing above a gas giant several times larger than Jupiter. Beneath you stretches an atmosphere thousands of miles deep, with no solid surface anywhere below. Only layers upon layers of gas, pressure, clouds, and darkness descending forever into the unknown. The clouds themselves may not even be made of water. On hotter planets, clouds could consist of vaporized rock, molten metals, or silicate dust. Iron may condense into droplets and fall as metallic rain. Titanium clouds might glow orange beneath flashes of electrical storms larger than continents. And inside these atmospheres, storms are born. Some begin from extreme temperature differences between the day side and night side of tidally locked planets. One half of the world permanently faces its star, burning beneath eternal daylight, while the other remains trapped in endless freezing darkness. The atmosphere tries constantly to balance these extremes. Heat rushes across the globe in colossal jet streams, moving thousands of miles per hour. Entire hemispheres become locked in giant rotating vortices. Clouds twist into spirals wider than solar system's inner planets. On certain hot Jupiters, scientists have measured winds exceeding 5,000 miles per hour, faster than the speed of sound on Earth. At those speeds, storms no longer resemble anything familiar to us. They become planetary engines, endlessly redistributing heat across worlds where the atmosphere itself is always in motion. And the lightning there may be unlike anything humanity has ever witnessed. Here on Earth, lightning forms inside water clouds. But on alien storm worlds, lightning could emerge inside clouds of ash, iron vapor, or silicate particles. Some flashes may be hundreds of times stronger than terrestrial lightning, illuminating entire hemispheres for brief moments. A single storm could rage continuously for centuries, perhaps even millennia. There may be moons orbiting these giant planets, passing silently beneath endless storms generation after generation. Entire civilizations, if they existed there, might live and disappear beneath a sky where one storm has never ended, a permanent hurricane dominating the heavens forever. Some gas giants may even possess storm systems so enormous they interact with one another like living structures. Massive vortices colliding, jet streams weaving together, atmospheric bands wrapping around the planet in endless layers of color and turbulence. From space, these planets might appear strangely beautiful, swirling blues, reds, silvers, and golds, turning slowly beneath distant starlight. But inside those clouds lies unimaginable violence. The deeper you descend into a gas giant, the more terrifying the environment becomes. Pressure rises relentlessly. Hydrogen gas may eventually compress into exotic liquid forms. Deeper still, scientists believe hydrogen can transform into metallic hydrogen, a strange state of matter capable of conducting electricity. Somewhere far below the visible clouds, hidden oceans of compressed liquid may exist beneath crushing pressures no human technology could survive. And still the storms continue overhead. There may be no true silence anywhere on these worlds, only endless motion. Winds roaring through layers of atmosphere, lightning flickering across metallic clouds, thunder rolling for thousands of miles through gases we barely understand. Yet, despite all their violence, these storm worlds are also strangely mesmerizing, because storms are signs of energy, signs of movement, signs that a planet is alive with internal activity. A completely dead world is often still and frozen, but storm planets breathe. They churn and pulse beneath their clouds like giant living machines built by gravity and heat. Even more fascinating is the possibility that some moons orbiting these giant planets could remain surprisingly habitable despite the chaos above them. Large moons with thick atmospheres or underground oceans may circle safely within the magnetic embrace of their parent worlds. From their surfaces, the gas giant above would dominate the sky, an enormous striped sphere filling the heavens, while gigantic lightning storms flicker endlessly across its atmosphere like cosmic scars of light. Imagine watching storms larger than Earth unfolding every night overhead, not for a single season, but for your entire lifetime. Astronomers believe many of these storms may form because giant exoplanets rotate extremely quickly. Some complete a full rotation in only a few hours. That rapid spinning stretches atmospheric currents into enormous bands and amplifies weather systems into structures unlike anything on Earth. And some storms may never truly die. On Earth, hurricanes eventually weaken when they lose heat from warm oceans. But on giant gas planets, the entire atmosphere itself becomes the fuel. There are no continents to interrupt the storms, no mountains to weaken them, only endless gas feeding endless motion, an eternal cycle beneath alien skies. Perhaps somewhere tonight, deep within the galaxy, a giant planet is turning slowly around its distant star, while colossal storms glow across its atmosphere. Lightning flashes through clouds of vaporized metal. Winds scream across hemispheres wider than worlds. Moons drift quietly nearby, beneath the glow of endless hurricanes. And no one sees it. No one hears it. The storm simply continues in silence beneath the stars, a reminder that the universe is not always calm and empty. Sometimes it is wild, sometimes it is violent, and sometimes, hidden far beyond our solar system, entire planets spend billions of years trapped beneath oceans of lightning and storms that never end. Every star in the universe is living on borrowed time. No matter how bright, how massive or how eternal a star may appear in the night sky, somewhere deep inside its core, the slow countdown toward death has already begun. Stars shine because they burn. They survive by turning hydrogen into light. But eventually, even the greatest suns run out of fuel. And when they do, entire worlds must witness the ending. Some planets spend billions of years orbiting their stars in quiet stability. Oceans rise and fall, atmospheres drift, moons circle faithfully overhead. Life, perhaps, begins beneath warm skies and gentle sunlight. Then, slowly, almost imperceptibly at first, the star changes. A dying star does not usually vanish in an instant. Most stars fade gradually through stages so vast that civilizations could rise and disappear without ever noticing the transformation has begun. For billions of years, stars like our Sun remain relatively stable. But deep within their cores, hydrogen steadily disappears. As the fuel diminishes, gravity begins to tighten its grip. The core contracts, temperatures rise, the outer layers swell outward. The star grows older, redder, larger, and eventually it becomes a red giant. If you stood on a distant planet orbiting such a dying sun, the sky would slowly begin to transform over millions of years. The star overhead would grow brighter and larger with every passing age. Temperatures would rise. Frozen worlds might briefly thaw beneath the expanding warmth. Oceans could awaken after billions of years trapped beneath ice. But the beauty would not last. As the star continues swelling outward, inner planets may be consumed entirely. Worlds that once circled peacefully for billions of years disappear beneath oceans of stellar fire. Their mountains vaporize, their atmospheres ignite, their surfaces melt into glowing rivers of rock before vanishing forever inside the star that once gave them life. One day, this will happen in our own solar system. Long after humanity is gone, the sun itself will expand outward and transform into a red giant. Mercury will almost certainly disappear. Venus likely will as well. Earth's fate remains uncertain, but even if our planet survives physically, its oceans will boil away and its skies will burn beneath unbearable heat. The quiet blue world we know today will become unrecognizable, and somewhere farther out, moons around Jupiter and Saturn may briefly warm beneath the dying sun's final expansion. Frozen landscapes may melt for the first time in billions of years under an aging orange sky. Even death changes worlds, but some planets survive. As stars like the sun near the end, they eventually shed their outer layers into space. Great glowing shells of gas drift outward like cosmic ghosts, creating what astronomers call planetary nebulae. At the center remains a white dwarf, a stellar corpse, small, dense, and slowly cooling in darkness. And astonishingly, some planets continue orbiting these dead stars long after the violence ends. Astronomers have discovered evidence of planets circling white dwarfs, surviving the destruction of their systems. Some may have moved outward during the star's expansion. Others endured unimaginable heat and gravitational chaos, only to emerge orbiting a cold stellar ember. Imagine standing on such a world. The star above you would no longer resemble a sun. Instead, it would appear as a tiny brilliant white point in the sky, no larger than a star seen from Earth, yet radiating enough heat to illuminate the planet beneath it. There would be no sunrise like ours, no golden dawn, only the pale light of a dying core slowly fading across eternity. And still, the planet continues turning. Some stars die far more violently. Massive stars end their lives in supernova explosions, powerful enough to outshine entire galaxies for brief moments. When these stars collapse, the explosion tears through nearby space with unimaginable force. Planets close to the star are usually destroyed instantly, atmospheres stripped away, surfaces scorched, entire worlds shattered into debris. But even here, survival may sometimes be possible. Planets orbiting distant companion stars in binary systems might endure the blast from afar. Some may survive wounded and altered forever beneath skies that suddenly exploded with light brighter than anything nature normally allows. For a brief period, night itself would disappear. The sky would blaze like a second sun. Then darkness would return, and the dead star's remnant would remain behind. Sometimes as a neutron star, sometimes as a pulsar, sometimes as a black hole. The universe leaves strange ruins after death. One of the most haunting discoveries in astronomy was the realization that planets exist around pulsars, the collapsed remnants of exploded stars. These neutron stars spin rapidly, sending beams of radiation through space like cosmic lighthouses. The first confirmed exoplanets ever discovered orbited such a dead star. Ghost worlds circling a stellar grave. No one expected planets could survive such violence, and yet they do. Again and again, the universe proves more resilient than we imagined. There is something strangely emotional about dying stars and surviving planets, because planets are witnesses, silent companions orbiting through every stage of stellar life. They are there during the bright beginning. They remain during the stable middle years, and some endure all the way to the final fading light. Perhaps somewhere in the galaxy tonight, there is a world orbiting an ancient white dwarf beneath dim silver skies. Oceans frozen, mountains silent, cities maybe, long vanished beneath the slow cooling of a dead sun. And overhead, the last remains of that star still glow faintly in the darkness, a final light refusing to disappear completely. The universe often feels violent and chaotic, but stellar death is also strangely quiet. These transformations unfold across millions or billions of years, slowly enough that mountains could erode while the sky changes almost unnoticed. Entire civilizations might spend their whole existence beneath a sun already dying without realizing it. And maybe that is part of what makes stars feel so eternal to us. Their endings happen too slowly for human eyes to fully comprehend. But they do end. Every sunrise anywhere in the universe is temporary. Every warm sky eventually cools. Every star will one day exhaust the fire inside it. And still planets continue orbiting, silent witnesses beneath fading light, holding on to gravity long after the stars themselves begin to die. Because in the universe, endings are rarely sudden. They are slow, quiet, and beautiful in ways almost too large for the human mind to hold. Darkness on Earth is never truly complete. Even in the deepest night, there is always some distant glow. Moonlight touches the oceans, cities shimmer on the horizon, stars quietly scatter themselves across the sky. But somewhere far beyond our solar system, there may be worlds where true night has lasted for billions of years. Planets that drift so far from their stars that sunlight barely reaches them at all. Worlds where the sky has never known a sunrise. And if you stood there, beneath that endless black ceiling, you might slowly forget what daylight even means. Far from the warmth of ordinary stars, there are planets that orbit at unimaginable distances. Some circle faint red dwarfs whose light barely escapes into space. Others may wander near the frozen edges of giant planetary systems where the star appears no brighter than a distant spark. On those worlds, the darkness would not feel temporary. It would feel eternal. The surface might be frozen solid beneath temperatures colder than Antarctica could ever imagine. Ice would stretch across endless plains, cracked by slow geological movement over millions of years. Mountains of frozen methane and nitrogen could rise silently beneath skies darker than charcoal. No forests, no blue horizons, no dawn waiting beyond the mountains. Only the stillness of a world locked away from warmth. Some of these planets may be tidally locked, always showing the same face to their star. If the orbit is distant enough, even the day side may resemble twilight rather than true daylight. The night side, meanwhile, would sink into permanent darkness colder than deep space itself. Scientists believe worlds like this may exist in enormous numbers across the galaxy. And strangely enough, they may not be entirely dead. Beneath thick layers of ice, hidden oceans could still survive. Deep underground, pressure and internal heat from radioactive decay may keep liquid water moving slowly through buried seas, untouched by sunlight. Similar oceans may already exist beneath the icy crusts of moons like Europa and Enceladus in our own solar system. But on distant exoplanets, these hidden oceans could be vastly larger. Entire alien seas concealed beneath miles of frozen darkness. If life exists there, it would never know the sun. No creature would evolve beneath a blue sky or watch clouds drifting overhead. Instead, life might gather around deep hydrothermal vents glowing faintly beneath black oceans. Strange organisms could feed on chemistry instead of light, surviving quietly in isolation for millions of years. The universe may be filled with living things that have never seen a sunrise, and perhaps that changes the way we think about life itself. On Earth, sunlight feels essential. Nearly every ecosystem depends on it. Plants capture its energy. Animals follow its rhythm. Even our sleep is shaped by the rising and setting of the sun. But the cosmos may not care about our assumptions. Life may adapt anywhere patience and energy exist, even in endless night. Some dark planets may not orbit stars at all. Rogue planets, cast out from their systems long ago, wander the galaxy completely alone. They drift through interstellar darkness without any sunrise, sunset, or seasons. Their skies remain permanently black, except for distant stars scattered like faint dust. At first, these lonely worlds seem impossible places for life, but beneath thick atmospheres of hydrogen, internal heat could remain trapped for billions of years. Some scientists believe certain rogue planets may still possess underground oceans insulated beneath ice and gas, warmth hidden beneath darkness, entire ecosystems concealed beneath frozen crusts, drifting silently between the stars. It is difficult to imagine such loneliness. No nearby sun, no neighboring planets glowing in the sky. Just a solitary world moving through the vast emptiness of the galaxy. And yet even there, physics continues its quiet work. Gravity still pulls, ice still shifts, water may still flow in hidden darkness. The universe rarely wastes possibilities. Some planets experience darkness in stranger ways. There may be worlds orbiting black holes or dead stars where light behaves unnaturally. On planets near collapsed stellar remnants, the sky could glow faintly with radiation, while the surrounding cosmos remains almost entirely black. Other planets may orbit dim brown dwarfs, objects too small to become proper stars. From the surface of such a world, the sun overhead might appear as a dull red ember rather than a bright star. Daylight would feel more like permanent dusk. A civilization evolving there might never understand how bright the universe can truly be. Their myths might describe impossible worlds flooded with blinding light, worlds like Earth. And maybe somewhere, far away, another civilization looks toward the darkness and imagines us as creatures living beneath an impossibly bright sky. The galaxy contains countless forms of night. Some are peaceful, some are terrifying. Some are so ancient that entire mountains may have risen and collapsed beneath skies that never changed at all. Yet, there is something strangely calming about these silent worlds. They remind us that the universe does not rush. On Earth, we live surrounded by movement and noise. Cities flash endlessly. Screens glow late into the night. Time feels fast and crowded. But out there, beyond the warmth of familiar sunlight, are planets where nothing changes quickly. Frozen landscapes wait quietly beneath ancient stars. Storms drift slowly through dark atmospheres over centuries. Ice cracks echo across empty plains no living ear may ever hear. And in that silence, the cosmos feels larger than we can truly understand. Perhaps that is why stories about distant worlds feel comforting at night, because they pull us away from the small urgency of everyday life. They remind us that existence is vast, ancient, patient. Even now, while you rest here, beneath Earth's familiar sky, somewhere in the galaxy, a frozen planet may be turning slowly through eternal darkness. Its oceans hidden below black ice, its mountains untouched by light, its silent horizon unchanged for billions of years. And maybe, deep beneath that frozen shell, warm water still moves quietly in the dark. A hidden sea beneath an endless night, a world waiting silently among the stars. Somewhere in the galaxy, there are worlds where rain does not fall like water. There are planets where the skies are so hot that rock itself melts into vapor. And high above those burning alien horizons, winds faster than sound carry shards of molten glass sideways through the atmosphere like endless storms of fire. If you stood there, even for a single second, the air itself would tear you apart. These planets are among the most violent worlds ever discovered. Many belong to a class known as hot Jupiters, giant gas planets orbiting impossibly close to their stars. Some circle their suns in just a few days, trapped so near the stellar furnace that temperatures climb beyond 2,000 degrees Fahrenheit. At those extremes, ordinary chemistry begins to change. Metals vaporize, stone softens. Clouds form not from water, but from silicates and mineral dust. On Earth, glass is something delicate. Smooth windows, shimmering bottles, tiny grains of sand melted by heat. But on these exoplanets, glass may exist inside the atmosphere itself. Scientists studying worlds like HD 18E 9733b discovered evidence suggesting silicate particles may condense high in the skies before being blasted sideways by enormous winds. These winds are so powerful, they never truly settle. The planet is tidally locked, meaning one side always faces the star while the other remains in permanent night. The day side burns beneath relentless heat. The night side cools slightly in darkness. And between them, the atmosphere rushes violently around the planet in a never-ending cycle. Jet streams scream across the globe at thousands of miles per hour, faster than hurricanes, faster than anything Earth has ever known. In those winds, molten particles may harden into tiny blades of glass. And instead of falling gently downward like rain on Earth, they race sideways through the atmosphere at supersonic speeds. A horizontal storm of burning shards, an endless hurricane of fire and glass. The skies on such a world would not look blue. They might glow deep cobalt, black purple, or metallic gray, depending on the chemistry suspended in the atmosphere. Lightning could flash through clouds of vaporized rock. The horizon might shimmer beneath layers of heat distortion, while entire continents of gas churn slowly beneath the storms. No oceans, no forests, no calm winds carrying rain across fields. Only heat, pressure, and violence beyond imagination. And yet, strangely, these planets are beautiful. From a distance, some may glow like polished gemstones floating beside their stars. Others reflect strange colors created by exotic minerals in their clouds. One world may appear sapphire blue, another bronze, another dark as coal. The universe paints with materials Earth barely understands. What makes these planets even stranger is that many were never expected to exist at all. Before exoplanets were discovered, astronomers believed giant gas planets could only survive far from their stars, where temperatures remained cold enough for gases to condense slowly during planetary formation. But then we found hot Jupiters, massive worlds orbiting so close to their stars that a single year might last only 2 or 3 Earth days. Their existence forced scientists to rethink how planets move and evolve. Some likely formed far away, before slowly spiraling inward over millions of years. Others may have been thrown into strange orbits through gravitational chaos long ago. Now, They circle their stars like cosmic sacrifices, slowly roasting beneath unbearable heat. Some are even losing their atmospheres entirely. Under intense radiation, hydrogen and helium expand outward into space, creating enormous tails of escaping gas behind the planet. In a sense, these worlds are evaporating, dying slowly beneath their suns, and still they continue orbiting. Still the storms rage. Still molten glass may fall endlessly through alien skies. On Earth, weather often feels comforting. Rain tapping softly against windows, snow drifting silently beneath streetlights, thunder rolling through distant clouds. But elsewhere in the galaxy, weather becomes something terrifyingly unfamiliar. There may be planets where iron condenses into rain, worlds where titanium vapor forms metallic snow, planets with clouds made from rock dust, and lightning storms large enough to swallow entire continents. Weather is simply chemistry shaped by temperature and pressure. And when those conditions change, nature invents entirely new skies. Some exoplanets may experience permanent storms that never weaken because their stars constantly heat one side of the planet more than the other. Others may have atmospheric currents so strong that heat itself is redistributed around the globe in giant rivers of gas. The atmosphere becomes an ocean in motion, a living machine of heat and wind. If an observer floated above one of these worlds, they might see glowing clouds twisting endlessly beneath them. Storm systems larger than Earth could spin for centuries without stopping. Bright flashes of lightning might illuminate the upper atmosphere, while rivers of molten material drift through the darkness below. And somewhere inside those storms, tiny shards of glass continue racing through the air, silent, relentless, beautiful in their own impossible way. These planets remind us how narrow Earth's comfort zone truly is. Our world feels stable because we were born here. We are used to blue skies, breathable air, and water falling gently from clouds. But the universe is under no obligation to create worlds that resemble home. Most planets are probably nothing like Earth. Most skies may never know rainwater. Most winds may never feel soft. The cosmos builds worlds from whatever materials it has available. Sometimes ice, sometimes fire, sometimes oceans hidden beneath frozen darkness, and sometimes storms of molten glass beneath burning stars. Yet even these violent worlds hold wonder, because every strange exoplanet expands the boundaries of imagination. Each discovery reminds us that reality is far more creative than fiction. There are planets where mountains may melt, worlds where clouds are made of gemstones, skies where metal falls like snow, and perhaps somewhere tonight, far beyond the reach of our telescopes, a giant alien storm is still raging across a distant atmosphere. Glass slicing sideways through black clouds, lightning flashing through burning skies, winds screaming endlessly around a world too strange for ancient humans to ever dream existed. And still, despite all its violence, the planet keeps turning quietly beside its star. Another impossible world, drifting through the endless dark. There are planets in the galaxy where simply standing up might feel exhausting. Worlds so massive and dense that gravity pulls at everything with crushing force. If you stepped onto one of these super Earths, your own body would suddenly feel heavier than you ever thought possible. Your legs would strain beneath you. Every movement would slow. Even lifting your arms might feel like pushing against invisible water. And after only a few moments, you would realize something unsettling. Gravity is not just a force, it is a feeling. Here on Earth, we rarely think about it. Gravity quietly holds oceans to the planet, keeps our feet on the ground, and guides the moon through its orbit. It feels normal because we have never known anything else. But elsewhere in the universe, gravity can become something far stranger. Super-Earths are rocky planets larger and more massive than our own world. Some may be 2 or 3 times Earth's size. Others could contain up to 10 times Earth's mass packed into dense interiors of iron and stone. These are not gas giants like Jupiter. They are solid worlds, massive mountains, heavy skies, immense pressure locked beneath alien surfaces. Astronomers have discovered many of these planets orbiting distant stars. Some lie within habitable zones where temperatures may allow liquid water. Others circle dangerously close to their suns, glowing beneath intense heat. But what makes them fascinating is not just their size, it is how different life might feel there. On Earth, gravity shapes every living thing. Trees can only grow so tall before their own weight becomes too much. Birds evolved hollow bones to fly more easily. Human muscles and skeletons developed under the exact pull of Earth's gravity over millions of years. Change that force, even slightly, and an entirely different world begins to emerge. On a super-Earth with twice our gravity, walking could feel exhausting. Running might become nearly impossible. Jumps would barely leave the ground. Mountains may rise lower and broader because rock itself struggles against the planet's immense pull. The atmosphere could also become thicker. Denser air might create endless fogs or deep cloud layers stretching across the sky. Weather systems could move differently beneath the heavy atmosphere. Rain might fall more slowly. Winds may feel sluggish near the surface, while violent pressure systems build high above. Even sound itself might travel differently. And if oceans exist there, they could be unimaginably deep. Gravity compresses everything inward. Water presses harder against the seafloor. Ice forms under enormous pressure. Deep beneath the surface, exotic layers of superheated water and strange mineral structures may exist unlike anything found on Earth. The deeper you go, the stranger the planet becomes. Some super-Earths may possess enormous metallic cores, generating powerful magnetic fields. Auroras could spread across the sky in brilliant curtains of green and violet light. Others might experience extreme volcanic activity as internal heat struggles to escape through thick crusts. Entire landscapes may constantly reshape themselves beneath crushing gravity. And still, despite their alien nature, these worlds may be among the best places to search for life. For years, scientists assumed Earth-sized planets were the most likely homes for biology. But now, some researchers suspect super-Earths might actually offer even more stable environments. A larger planet can retain internal heat longer. Its magnetic field may survive for billions of years. Its atmosphere might remain protected from stellar radiation, far better than smaller planets like Mars. Some super-Earths may have existed quietly for ages beyond human imagination. Ancient oceans turning beneath heavy clouds, rain falling across dark coastlines, perhaps even forests growing under thicker skies and stronger gravity. If life evolved there, it would likely look very different from life on Earth. Creatures may grow shorter and sturdier to withstand the planet's pull. Flying animals, if they exist, might need enormous wings or dense air currents to remain airborne. Trees may spread outward rather than upward. Everything adapts to gravity eventually. Because gravity is the architect of worlds, it determines how planets form, how atmospheres behave, how stars gather matter, and how galaxies move through the universe. Even black holes, the darkest objects in existence, are born from gravity overwhelming everything else. In a sense, gravity writes the structure of reality itself, and on super-Earths, that structure becomes heavier, deeper, and more intense. Some of these planets orbit red dwarf stars, where the sunlight glows dim crimson across the surface. Others circle yellow suns, not unlike our own. A few may even drift beneath permanent cloud layers, where the stars are never visible at all. Imagine standing there. The horizon feels familiar, yet wrong. The ground beneath your feet presses upward with enormous force. Your breathing feels heavier. Every object seems unusually solid and difficult to move. Even your own heartbeat might sound louder inside your chest. The sky above could appear thicker, darker near the horizon, perhaps glowing orange beneath layers of dense atmosphere. And somewhere far overhead, massive clouds drift slowly across an alien world built from pressure and stone. The universe seems filled with extremes: planets where gravity barely exists, and worlds where it dominates everything. Tiny moons where a human could leap across cliffs with ease, and super-Earths where every step becomes a struggle against the planet itself. Yet somehow, these worlds are not hostile mistakes. They are natural outcomes of cosmic creation. The galaxy experiments endlessly with size, chemistry, temperature, and force. Every star system becomes its own version of reality. Some planets rain molten glass, some hide oceans beneath black ice, and some wrap themselves in gravity so powerful that even standing still becomes an effort. Still, there is something strangely calming about knowing these places exist. Tonight, while Earth turns quietly beneath familiar gravity, countless other worlds are spinning through the darkness under entirely different rules. Heavy worlds, silent worlds, planets where the weight of the sky itself may feel immense. And perhaps somewhere far away, beneath the thick clouds of a super-Earth, rain is falling softly onto an alien ocean, while strange life moves carefully across the heavy ground below. The universe continues building worlds beyond imagination, one gravity at a time. And if you're still awake out there beneath Earth's quiet sky, leave a like and let the universe know you're listening. Far beyond the warmth of familiar suns, there may be worlds where ice has ruled for billions of years. Planets so distant from their stars that daylight arrives only as a dim blue haze across frozen horizons. In those remote regions of the galaxy, temperatures fall so low that methane, ammonia, and nitrogen freeze into solid crystal landscapes. Entire mountains may glitter beneath weak starlight, like fields of broken glass drifting endlessly through the dark. These are not worlds of forests, oceans, or rain. They are silent kingdoms of frost, where even the atmosphere moves slowly, almost reluctantly through the cold. Imagine standing there for a moment. Above you, the sky would not look black like space from Earth. Instead, it might glow with deep cobalt tones, mixed with pale silver clouds suspended motionless in the freezing air. The distant star overhead would appear tiny and faint, more like a bright star than a sun. Shadows would stretch for miles across the icy plains, sharp and perfectly still beneath the dim light. Nothing would move quickly on a world like this. The winds would whisper instead of howl. Snow made of frozen methane might drift across the surface in slow shimmering waves. In some places, the ground itself could creak softly as ancient glaciers of nitrogen ice shift beneath their own weight over thousands of years. These frozen exoplanets may resemble Pluto or Neptune's distant moons, but on a far grander scale. Entire worlds trapped in permanent winter, where chemistry itself paints the landscape in strange colors. Some regions may glow pale pink from frozen hydrocarbons. Others might shine blue beneath reflective sheets of crystalline ammonia ice. And despite their harshness, these planets may be among the oldest survivors in the galaxy. Many orbit quietly at the outer edges of ancient star systems, far away from violent radiation and stellar chaos. While inner planets burn, collide, or lose their atmospheres, these distant frozen worlds remain untouched, preserving conditions that may not have changed for billions of years. Time itself feels slower there. A sunrise might take hours to fully appear above the horizon. Twilight could linger for days beneath the weak light of a dying star. Seasons may last centuries, with temperatures barely changing at all across generations. Some of these planets may even possess hidden warmth beneath their frozen crusts. Deep below miles of black ice, internal heat from radioactive elements could keep underground oceans liquid. Hidden seas sealed away from the universe above. Oceans that no sunlight has touched since the beginning of their world. On Earth, we already see hints of this possibility on moons like Europa and Enceladus. Beneath their icy shells, vast oceans may move silently in darkness. If such places exist in our own solar system, then across the galaxy, there may be countless frozen planets hiding secret oceans beneath their surfaces. And in those hidden waters, chemistry continues. Minerals dissolve. Heat rises slowly from the core. Tiny hydrothermal vents may release warmth into the darkness, exactly like those found deep beneath Earth's oceans. Life on our planet thrives around such vents, even without sunlight. Which raises a strange and beautiful possibility. Maybe not all life needs a bright blue sky. Perhaps somewhere beneath alien ice, tiny organisms drift through warm black oceans, completely unaware of stars above them. Entire ecosystems may survive in darkness, feeding not on sunlight, but on chemistry and heat from the planet itself. If intelligent life ever evolved there, their understanding of the universe would be unimaginably different from ours. They might never see the stars. Imagine civilizations born beneath miles of frozen ice, living beside glowing thermal oceans in eternal darkness. Their myths would not speak of suns or constellations. The universe above might remain unknown to them for millions of years, hidden behind an endless ceiling of ancient ice. And yet, even these frozen worlds are not entirely lifeless on the surface. Some exoplanets may experience strange forms of weather despite the cold. Thin atmospheres could create drifting methane fogs or slow electrical storms glowing faintly across the horizon. Frozen particles suspended in the air may reflect distant starlight, causing the surface to shimmer beneath the dark sky like fields of diamonds. On certain planets, cryovolcanoes may erupt instead of normal volcanoes. Rather than molten lava, they release icy mixtures of water, ammonia, and methane into the freezing air. Great plumes of frozen vapor rise slowly before falling back as crystal snow. Over millions of years, these eruptions may reshape entire continents of ice. Everything there feels quiet. Even catastrophe arrives slowly on frozen worlds. Mountains collapse over centuries. Glaciers move the width of a hand every year. Oceans hidden below thick ice may churn silently while the surface remains unchanged for ages longer than human civilization has existed. And perhaps that silence is what makes these planets feel so mysterious. In the crowded imagination of science fiction, we often picture alien worlds as loud places filled with giant cities, flashing lights, or endless battles among the stars. But the real universe may be far stranger and far quieter, because most planets in the galaxy are probably not warm Earth-like worlds. Many may be frozen wanderers orbiting dim red stars or drifting through the cold outer reaches of ancient systems. Places where darkness stretches endlessly across fields of silent ice. Places where time moves slowly enough that entire civilizations could rise and disappear beneath the same frozen sky. Some of these worlds may never be visited. They are simply too far away, too cold, too distant from the warmth of human life. And yet they exist. Right now, somewhere in the Milky Way, frozen planets are turning silently beneath faint stars while their hidden oceans continue moving below. The universe is full of places like this, quiet worlds, sleeping worlds, worlds waiting patiently in the dark. Some planets in the galaxy are so ancient that they were already circling their stars long before Earth was born, before our oceans formed, before the dinosaurs walked, before the sun itself even existed. Somewhere in the Milky Way, there are worlds that have survived for 10 billion years or more, quietly orbiting through cosmic history while entire generations of stars rose and vanished around them. These planets are older than mountains, older than oceans, older than almost everything we know. They are the elders of the galaxy. When we look up into the night sky, it is easy to imagine the universe as something distant and timeless. But every star has an age. Every planet has a beginning. And some of those beginnings happened so far in the past that human minds struggle to truly understand the scale. Earth formed about 4.5 billion years ago. At that time, the Milky Way was already ancient. Stars had been living and dying for billions of years before our planet ever cooled enough for oceans to appear. Somewhere during that vast stretch of cosmic time, the first generations of planetary systems emerged around older stars. And incredibly, some of them still exist today. Astronomers have discovered planetary systems estimated to be 10 or even 11 billion years old. These worlds formed when the universe itself was still young, when heavy elements were rare, and galaxies looked very different from the calm spiral structure we see today. Imagine standing on such a planet. The ground beneath your feet would belong to a world older than Earth by billions of years. Every mountain, every stone, every frozen plain may have existed before our sun ever ignited. While our planet was still dust drifting through interstellar space, these ancient worlds were already turning quietly beneath alien skies. And they endured. They survived supernovas exploding nearby. They survived galactic collisions. They survived ages of cosmic violence that reshaped entire regions of the Milky Way. Through it all, they continued orbiting their stars in silence. Some of these ancient systems may look surprisingly peaceful today. Their stars have aged into calm, stable suns, glowing softly after billions of years of burning hydrogen. Their planets may orbit in quiet rhythms, unchanged, for longer than multicellular life has existed on Earth. But the universe they were born into was not peaceful. In the early galaxy, stars formed rapidly inside crowded regions filled with radiation and violent explosions. Heavy elements like iron, oxygen, and carbon were far less common than they are now. Scientists once believed planets may have struggled to form in such ancient environments, but the galaxy proved more creative than expected. Again and again, astronomers discovered planets orbiting extremely old stars, proving that worlds began forming almost as soon as the universe allowed it. Gravity wasted no time. As soon as enough material existed, dust began clumping together inside swirling disks around newborn stars. Rocks formed, then worlds. And some of those worlds are still here. One remarkable system, known as Kepler 444, contains 5 rocky planets orbiting a star more than 11 billion years old. When these planets formed, our solar system did not exist. Earth would not appear for another 6 billion years. That means if life ever emerged there, it could be unimaginably ancient. Civilizations, if they ever rose on worlds like these, may have had billions of extra years to evolve before humanity even existed. Entire histories beyond comprehension may have unfolded beneath those old skies, while Earth was still molten rock drifting through cosmic darkness. It is a thought both beautiful and unsettling, because ancient planets force us to confront how young we truly are. Human civilization has existed for only a tiny moment compared to the age of the cosmos. Even dinosaurs lived closer to us in time than Earth's birth is to the formation of some ancient exoplanets. Against the scale of the galaxy, humanity is almost impossibly new. And yet these worlds continued turning long before us. Some ancient planets may now be cold and lifeless. Their stars may have dimmed over billions of years, slowly changing the climates of worlds that once held warmth. Oceans may have frozen. Atmospheres may have escaped into space. Continents may have shifted endlessly beneath skies that gradually darkened with time. Others may still remain stable and calm. Red dwarf stars, especially, can live for trillions of years, far longer than stars like our Sun. Planets orbiting quiet red dwarfs may enjoy stable conditions for periods so vast that life would have almost unimaginable amounts of time to develop complexity. On Earth, intelligent life emerged after roughly 4 billion years. But what happens on a world that had 10 billion years? Would life remain simple? Or would evolution create forms of intelligence so ancient that human history would seem like the blink of an eye? We do not know. For now, these planets remain distant points of light hidden among billions of stars. We cannot walk across their surfaces or study their ancient oceans directly. But through careful observations of starlight, gravity, and planetary motion, we know they are there, silent witnesses to cosmic history, ancient worlds orbiting through eras we can barely imagine. Perhaps some of them watched neighboring stars explode long before Earth formed. Perhaps their skies changed slowly over billions of years while galaxies collided in the distance. Perhaps frozen deserts there have remained untouched since before our sun existed. There is something strangely calming about these worlds. They remind us that the universe is patient. Stars burn slowly. Planets drift quietly. Time stretches across unimaginable distances without hurry. And somewhere tonight, beneath skies older than Earth itself, an ancient planet continues its endless orbit around a fading star. Its mountains remain cold and silent. Its oceans, if they still exist, move beneath the dark exactly as they have for billions of years. A world older than memory, older than humanity, older than home itself. Every star eventually dies. Some fade quietly over billions of years, shrinking into dim white dwarfs. Others explode violently in supernovas so powerful they briefly outshine entire galaxies. We often imagine these deaths as endings, moments when everything nearby is erased forever beneath fire and radiation. But the universe is stranger than that, because even after stars die, some planets remain. Somewhere in the galaxy tonight, there may be worlds still orbiting the burned-out remains of stars that no longer shine with life. Silent planets circling stellar ghosts. Worlds that survive the destruction of the suns that once warmed them. It sounds impossible at first. How could a planet endure the death of a star? The final moments of a massive star are unimaginably violent. When nuclear fusion ends, gravity crushes the star inward before an explosion tears through space at millions of miles per hour. Radiation floods nearby systems. Shock waves rip apart matter. Entire planetary systems may be shattered or scattered into darkness. And yet, astronomers have discovered evidence that some planets survive. In fact, the very first confirmed exoplanets ever found were orbiting a dead star. Not a normal star, a pulsar. A pulsar is the collapsed core left behind after a massive star explodes. It is a neutron star so dense that a single spoonful of its material would weigh billions of tons. Though the original star has died, the remnant continues spinning rapidly, sending beams of radiation into space like a cosmic lighthouse. For years, scientists believed no planet could survive such devastation. Then came a discovery that changed astronomy forever. In 1992, astronomers found planets orbiting the pulsar PSRB 1257+12. Entire worlds circling the remains of a star long after its death. The discovery stunned scientists because it revealed something extraordinary. Planetary systems can outlive stars. Imagine standing on one of those worlds. There would be no warm yellow sunlight overhead, no gentle sunrise or familiar blue sky. Instead, the heavens might glow faintly beneath pulses of radiation sweeping through space with eerie precision. The dead star above would appear small and terrifyingly dense, spinning rapidly in darkness. The light there would feel wrong, cold, artificial almost. A pulsar does not shine like a living sun. It flashes again and again, a heartbeat in the void. Some surviving planets may have endured the original supernova itself, battered by radiation, yet somehow remaining gravitationally bound to the stellar remnant afterward. Others may have formed later from debris left behind after the explosion, worlds born from the ashes of destruction itself. Either possibility feels haunting: a planet surviving the death of its sun, or a new world forming around a corpse. And pulsars are not the only dead stars hosting planets. Astronomers have also discovered evidence of worlds orbiting white dwarfs, the quiet remnants left behind when smaller stars like our Sun eventually exhaust their fuel. Unlike supernovas, these deaths happen slowly. The star swells into a red giant, consuming nearby planets before shedding its outer layers into space. At the center remains a dense glowing core about the size of Earth. A white dwarf, tiny, hot, slowly cooling across billions of years. Some planets may survive this transformation by orbiting far enough away to avoid destruction. Others may migrate inward later after the chaos settles. And some evidence suggests entirely new planets could form from leftover material surrounding the dead star. If you stood on one of these distant worlds, the sky would feel deeply unfamiliar. A white dwarf emits pale, ghostly light, far dimmer than a living star. Daytime might resemble permanent twilight. Shadows would stretch softly across frozen landscapes beneath a small glowing star, no larger than a bright moon in the sky. And yet, the planet would continue turning. Life, if it somehow existed there, would evolve beneath the fading warmth of a dying sun. There is something deeply emotional about these systems. They remind us that endings in the universe are rarely simple. Death does not always erase everything. Sometimes worlds remain behind, carrying the memory of stars that no longer burn. Ancient survivors drifting through cosmic silence. Some of these planets may bear scars from catastrophe. Their atmospheres could have been stripped away during stellar explosions. Their surfaces may be covered in radioactive debris or shattered by gravitational chaos. Entire oceans might have boiled away beneath waves of radiation during the death of their parent star. Others may now be frozen wastelands orbiting dim stellar embers. But still they endure, still circling, still moving through darkness long after the bright age of their systems has ended. There is also a strange possibility scientists sometimes consider. If intelligent life ever existed on worlds around dying stars, what would they witness as their skies changed? Imagine a civilization watching its sun slowly swell larger across thousands of generations, oceans evaporating, temperatures rising. The once stable sky becoming redder and brighter year after year. Eventually the star dies, the heavens erupt in fire, and somehow their world survives, a lonely planet orbiting the corpse of its own sun. Perhaps beneath the dim light of a white dwarf, ruins of ancient civilizations remain frozen beneath dust. Silent cities facing a sky forever changed. Oceans gone, air thin. The warmth of the old sun, only a memory preserved in forgotten stories. It is impossible not to feel small when thinking about such places, because stars themselves seem eternal to us. Human lives are too short to witness stellar death firsthand. The sun has shone over Earth for all of recorded history and far beyond. It feels permanent, but the universe reminds us otherwise. Stars live, stars die, and still the planets continue turning. Somewhere tonight, beyond the reach of our telescopes, a world may be orbiting quietly around the dead remains of a once brilliant star. No sunrise warms its surface anymore. No golden daylight fills its skies. Only the faint glow of a stellar ghost lingering in the dark. A planet after the end. A survivor beneath a dead sun. Still drifting, still waiting, still there. Far out in the darkness of space, entire planetary systems move in patterns so precise that if you could hear gravity itself, the universe might sound like music. Not chaotic noise, not random motion, but rhythm. Perfect, repeating rhythm unfolding silently across millions of miles and billions of years. When we first imagined other solar systems, we assumed they would resemble ours. Planets orbiting quietly in independent paths around their stars. But as astronomers discovered more exoplanets, something remarkable began to appear. Some planetary systems move almost like choreography. One planet circles its star exactly twice, for every 3 orbits completed by another. A neighboring world may move 4 times during the same period. Farther out, another planet joins the pattern in perfect synchronization, held in place by gravity's invisible pull. These arrangements are called orbital resonances, but in many ways, they resemble cosmic music. Imagine floating far above one of these systems. Below you, worlds move through darkness in elegant mathematical harmony. Each orbit affects the others through tiny gravitational nudges, repeated over and over again across enormous stretches of time. If a planet drifts slightly from its rhythm, gravity gently pulls it back into place. The result is stability born from repetition, a silent cosmic dance. Here on Earth, music emerges through patterns. Notes repeat, rhythms align, vibrations interact to create harmony. And strangely, the same thing happens in space. The planets themselves become moving notes inside an enormous gravitational composition written by physics. One of the most beautiful examples we know is the TRAPPIST-1 system. 7 rocky planets orbit a dim red star smaller than our Sun. They move incredibly close together compared to the planets in our solar system. Yet despite this crowded arrangement, the system remains stable because many of the planets are locked into orbital resonance. Each world keeps time with the others. Their years are connected. If one planet completes 8 orbits, another may complete 5, another completes 3. The ratios remain astonishingly precise, almost like gears inside an ancient cosmic clock. And all of it happens silently. No sound travels through the vacuum of space. These planets do not hum or sing in any literal sense. Yet mathematically, their motion resembles harmony so closely that scientists sometimes convert their orbital frequencies into audible tones. When translated into sound, the result feels haunting. Slow repeating pulses, deep resonant patterns, music written not by instruments, but by gravity itself. There is something deeply calming about imagining such systems, worlds moving together in darkness without collision. Giant planets drifting through endless night, while invisible forces guide them into stable patterns that may last billions of years. Some resonant systems have likely remained unchanged longer than Earth has existed. While civilizations rise and disappear on tiny worlds like ours, these planets continue their endless dance beneath distant stars. Orbit after orbit. Year after year, perfect timing preserved across unimaginable stretches of cosmic time. And perhaps the strangest part is this: the planets do not choose these rhythms. Gravity creates them naturally. Over millions of years, migrating planets pull on one another repeatedly until stable patterns emerge. Worlds become locked together like pendulums synchronizing inside a clock. Chaos slowly transforms into order. The universe improvises harmony. Some astronomers believe resonance may even help planetary systems survive. These balanced gravitational relationships can prevent collisions and stabilize orbits, allowing multiple planets to exist close together without destroying one another. Without resonance, some systems might collapse into chaos. With it, they become beautifully stable. Imagine standing on a planet inside one of these systems. Its sky would never remain the same for long. Neighboring planets might appear enormous overhead, drifting visibly across the heavens night after night. Some may glow brighter than Earth's moon, suspended above alien oceans or frozen deserts. And their motion would follow predictable cycles. Ancient civilizations living there might discover orbital patterns long before inventing modern science. They would watch neighboring worlds rise and fall through the sky with almost musical regularity. Entire calendars, myths, and philosophies might emerge from the rhythms overhead. Perhaps they would eventually realize something extraordinary. Their planet is not moving alone. It is part of a larger harmony. Even our own solar system contains traces of this hidden order. Jupiter's moons Io, Europa, and Ganymede orbit in resonance. Every time Ganymede circles Jupiter once, Europa circles twice, and Io circles 4 times. Their gravity pulls on one another constantly. Those interactions generate internal heat, shaping volcanoes and hidden oceans beneath ice. In this way, orbital resonance does not merely organize planetary systems. It can transform worlds themselves. Gravity becomes architecture, music becomes geology, and sometimes, perhaps, the conditions necessary for life. The deeper astronomers study planetary systems, the more they realize the universe is filled with patterns hidden beneath apparent chaos. Nothing moves randomly for long. Gravity connects everything together through invisible threads stretching across space. Stars pull planets, planets pull moons, moons pull oceans, and across billions of years, motion settles into rhythm. There is something almost poetic about that idea. The universe is often described as violent and chaotic. Supernovas explode, black holes collide, galaxies crash together. Yet hidden beneath that violence is astonishing order, a quiet mathematics guiding worlds through darkness with incredible precision. It reminds us that nature does not need intention to create beauty. Sometimes beauty simply emerges from motion repeated patiently enough. Some resonance systems may eventually break apart. A passing star, a migrating giant planet, or subtle gravitational instabilities may one day disrupt the harmony. Worlds could collide or drift into chaos after billions of years of balance. But until then, the dance continues. Silent, precise, endless. Somewhere tonight, far beyond the reach of human eyes, planets are circling their stars in perfect rhythm beneath alien skies. Giant worlds drift through darkness, while neighboring planets answer each movement with motions of their own. An orchestra with no conductor, a symphony with no sound, only gravity moving patiently through the dark, shaping harmony from silence itself. There are worlds in the galaxy where the night sky may never truly become dark, not because of nearby cities or bright moons, but because the heavens themselves are alive with light. Curtains of glowing color stretching endlessly from horizon to horizon. Rivers of green, violet, blue, and crimson drifting across alien skies in slow motion, like luminous waves moving through the atmosphere. On some exoplanets, auroras may never end. Here on Earth, auroras are rare and beautiful events. They appear near the poles when charged particles from the sun collide with our atmosphere, guided by Earth's magnetic field into glowing patterns across the night sky. For a few quiet hours, the heavens shimmer with color before fading again into darkness. But elsewhere in the universe, the conditions may be far more extreme. Some exoplanets orbit close to highly active stars that constantly release enormous storms of charged particles into space. Others may possess magnetic fields far stronger than Earth's. When those two forces interact, the result could be permanent auroras so vast and powerful that they illuminate entire hemispheres continuously. Imagine standing on such a world. Above you, the sky would pulse softly with moving light every hour of every day. Great glowing arcs would drift across the heavens like living oceans suspended in the atmosphere. Colors might ripple slowly from green to electric blue to deep crimson depending on the gases present in the planet's air. The stars beyond may appear blurred behind the glow. Night itself would feel alive. On some planets, the auroras may not remain near the poles like they do on Earth. Instead, they could stretch across the entire planet, circling the equator in giant luminous bands visible from space. Entire continents might exist beneath skies permanently painted with flowing light. And unlike Earth's gentle auroras, these displays may be unimaginably intense. Some giant exoplanets orbiting close to their stars are bombarded by radiation thousands of times stronger than what Earth experiences. Their magnetic fields could trap enormous amounts of charged energy, creating auroras bright enough to cast shadows across the surface below. If you stood beneath them, the landscape itself might glow faintly beneath shifting curtains of color. Mountains bathed in violet light, frozen oceans reflecting rivers of green fire overhead, alien deserts illuminated by endless electric storms moving silently through the sky. The beauty would feel almost supernatural. And yet, it would all be created by physics, magnetic fields, charged particles, atmospheric chemistry, the universe taking invisible forces and transforming them into moving light. Some tidally locked exoplanets may be especially breathtaking. These worlds always keep one side facing their star, while the other remains in permanent night. Along the dark hemisphere, constant streams of stellar radiation may collide with the atmosphere endlessly, creating giant auroral storms that never disappear. Imagine living there. One side of the planet burns beneath eternal daylight. The other glows beneath endless auroras. Between them lies a twilight region where dim sunlight meets rivers of shifting color overhead. A sky unlike anything human eyes evolved to see. Even gas giants may host auroras beyond imagination. In our own solar system, Jupiter already produces auroras far larger and more powerful than Earth's. They burn constantly near its poles, fueled not only by the solar wind, but also by volcanic material ejected from its moon Io. Now imagine a giant exoplanet, many times larger than Jupiter, orbiting closer to a more violent star. Its magnetic field could stretch millions of miles into space. Its auroras could wrap around the entire planet like glowing rings. From afar, astronomers might detect flashes of radio waves or faint emissions of light, revealing the presence of these enormous magnetic storms. In some cases, auroras may even help scientists discover hidden exoplanets that are otherwise invisible. The sky itself becomes evidence. There is something strangely comforting about these worlds. Auroras are reminders that planets are not isolated objects, drifting silently through darkness. They are connected to their stars through invisible exchanges of energy. Space is not empty. It is alive with particles, radiation, gravity, and magnetic forces constantly shaping the skies of distant worlds. On Earth, we rarely think about our magnetic field protecting us. But without it, the solar wind would slowly strip away our atmosphere. Our auroras are signs of that invisible shield quietly defending life below. Elsewhere in the galaxy, those same interactions may create spectacles beyond imagination. And perhaps life exists beneath some of those glowing skies. If alien civilizations live on planets with permanent auroras, their myths and art would be shaped by light moving constantly overhead. Children born there may grow up believing the sky itself is alive. Entire cultures might navigate by shifting ribbons of color stretching across the heavens every night. Their stories would not speak of dark skies filled only with stars. They would speak of oceans of light, and maybe those lights would influence more than imagination. On Earth, auroras can interfere with electronics and generate powerful magnetic disturbances. On extreme exoplanets, permanent magnetic storms may shape weather, climate, and even the biology of living things. Creatures evolving beneath those skies might perceive magnetic fields directly, sensing invisible forces flowing through the atmosphere around them. The universe often feels cold and empty from a distance, but worlds like these remind us that it is also astonishingly beautiful. Not quiet black emptiness, but motion and color unfolding endlessly across unimaginable distances. Somewhere tonight, beneath a distant red star, a planet may be turning slowly through darkness, while rivers of emerald light drift silently overhead. Frozen mountains glow beneath electric skies. Vast magnetic storms ripple across the atmosphere in patterns older than human civilization, and no one may be there to witness it. At least, not yet. Still, the light continues. moving patiently through the dark. A silent dance between star and planet written across the heavens themselves. And if these distant skies make your own worries feel smaller tonight, stay with us for the rest of the journey. There are planets in the universe that seem impossible at first glance. Worlds so strange, so extreme, that when astronomers first discovered them, many believed the data had to be wrong. For decades, scientists built careful models of how planetary systems should form. Small rocky planets near the star, giant gas worlds farther away, calm circular orbits, predictable motion, a kind of quiet cosmic order. But then the universe answered with something entirely different. It revealed planets where none should exist at all. Some orbit so close to their stars that a single year lasts only a few hours. These worlds race around their suns at terrifying speed, completing an orbit before a human being could finish a night of sleep. Their surfaces are blasted by radiation so intense that rock may melt into rivers of lava beneath skies glowing red with heat. Astronomers once believed giant planets could never survive so close to a star. The heat and stellar winds should have destroyed them long ago. And yet they exist. These planets are called hot Jupiters, enormous gas giants orbiting closer to their stars than Mercury is to the Sun. Their discovery shocked astronomy because our own solar system contains nothing like them. According to older theories, giant planets were supposed to form far away in the cold outer regions where ice and gas could gather slowly over time. But the cosmos ignored those expectations. Somehow these giants formed far from their stars and later migrated inward, drifting through their solar systems like wandering titans. As they moved, they may have disrupted everything around them, scattering smaller planets, reshaping orbits, even destroying entire young worlds in the process. What remains is a giant planet hanging impossibly close to its star, swollen by heat and glowing faintly in the darkness. And stranger worlds followed. Astronomers discovered planets orbiting dead stars called pulsars, the collapsed remnants of supernovas. These stars are among the harshest objects in existence. They spin rapidly, blasting intense radiation into space like cosmic lighthouses. Before these discoveries, scientists believed no planet could survive such violence. But somehow, some did. Imagine standing on a world orbiting the corpse of an exploded star. Above you, the sky would not glow warmly like Earth's. Instead, pulses of radiation would sweep silently across the heavens as the dead star rotated again and again. Day and night might lose all meaning there. The star itself would no longer shine through fusion. It would simply pulse endlessly, like the fading heartbeat of something ancient and broken. These planets should not exist. Yet gravity found a way. Some exoplanets are so enormous that they blur the boundary between planets and failed stars. Certain worlds possess more than 10 times the mass of Jupiter. Their gravity is immense. Their atmospheres stretch thousands of miles deep. Deep inside them, pressure may crush matter into forms we barely understand. Astronomers still debate where the line between giant planet and brown dwarf truly lies. At what point does a planet stop being a planet? The universe does not seem concerned with clear categories. It creates objects that exist somewhere in between. Not stars, not ordinary planets. Something stranger. And then there are the planets that barely orbit their stars at all. Some worlds travel on paths so vast that one orbit may take thousands of years. Their stars would appear distant even from their own skies, shining more like brilliant stars than suns. In the deep cold of those outer regions, temperatures drop low enough for methane, nitrogen, and ammonia to freeze into exotic snows. Entire landscapes may glitter beneath pale blue darkness, while frozen winds drift silently across endless plains. Other planets travel in the opposite direction of their star's rotation entirely. Imagine watching a sunrise that moves against the natural flow of the system itself. a planet spinning backwards through space, defying the quiet rhythm shared by most worlds. These retrograde planets likely suffered violent pasts, ancient collisions, gravitational encounters, catastrophic migrations that flipped entire worlds upside down. The universe keeps scars like these hidden inside orbital motion. Even more mysterious are rogue planets, worlds that belong to no star whatsoever. Long ago, many of them were likely born inside ordinary solar systems, but gravitational chaos threw them outward into interstellar darkness. Now they drift alone between the stars, endlessly wandering through the black ocean of the galaxy. No sunrise, no sunset, only silence. Some rogue planets may still hold heat trapped beneath frozen crusts. Deep underground oceans could remain liquid for billions of years, warmed by radioactive decay, hidden in their cores. In theory, life itself might survive there, beneath miles of ice, isolated forever from starlight. A lonely world floating through eternal night should not feel possible, and yet the galaxy may contain billions of them. Astronomers have also found planets orbiting two stars at once. In these systems, twin suns move through the sky together, casting overlapping shadows across alien landscapes. Sometimes the stars eclipse each other. Sometimes one rises while the other sets. The gravitational forces are incredibly complex, and for many years, scientists doubted stable planets could exist there. But again, nature proved more creative than expectation. Some of the strangest discoveries are planets that seem too lightweight to survive. Certain gas giants are so diffuse that, if placed in a giant ocean, they would float. Their atmospheres are puffed outward by intense heat until the planet becomes less like a solid world and more like a swollen bubble hanging in space. Others are the opposite, worlds so dense that their gravity compresses iron deep within their interiors into exotic states of matter. Standing there would feel crushing, every movement heavier, every breath more difficult. The planet beneath your feet would pull at your body with relentless force. These impossible worlds remind us of something profound. The universe is not obligated to behave in ways that feel familiar to us. For most of human history, we assumed our solar system was a template for the cosmos. We imagined other planetary systems would resemble our own because it was the only example we had. But every new telescope has revealed more exceptions, more strange arrangements, more alien possibilities. Planets raining molten glass, worlds covered in metallic snow, skies filled with vaporized rock, oceans hidden beneath frozen darkness. Gravity dances that lock entire systems into rhythmic motion, and planets that survive the deaths of stars themselves. Each discovery expands the imagination of humanity a little further. Somewhere out there tonight, beneath distant suns we will never touch, impossible worlds continue turning quietly through the dark. Their storms rage, their frozen oceans shift beneath ice. Their skies glow with unfamiliar colors. Their gravity shapes landscapes beyond anything Earth has ever known. And perhaps that is the most beautiful part of all. The universe is stranger than our first theories, stranger than our expectations, and far more creative than our fears. Every time we think we understand the cosmos, it opens another hidden door and reveals a world we never thought possible. Some planets may have rivers, rain, and seas, but not made of water. Far beyond the warmth of stars like our sun, there are worlds so cold that water becomes harder than stone. Ice there does not melt into oceans or fall as gentle rain. Instead, entirely different liquids take water's place. Methane, ethane, liquid hydrocarbons drifting beneath dim orange skies. On these distant planets and moons, alien weather quietly unfolds. Clouds gather, rain falls, rivers carve valleys, waves ripple across dark shores, but nothing is familiar. Imagine standing beside a shoreline where the sea before you is not blue, but black as oil beneath a faint copper sky. The air is bitterly cold, hundreds of degrees below freezing by Earth's standards. Every breath would crystallize instantly. Every exposed surface would become rigid with frost. And yet around you, weather still lives and moves. Rain still falls from clouds. Storms still gather over oceans. Nature still follows its endless cycles. Only the chemistry has changed. In our own solar system, Saturn's moon Titan offers the first glimpse of such a world. Beneath its thick golden atmosphere lie lakes and seas made not of water, but liquid methane and ethane. Rivers snake across its frozen surface exactly like rivers on Earth. Shorelines curve naturally. Rainstorms drift through the atmosphere. Dunes stretch across the landscape beneath skies permanently veiled in haze. Titan showed humanity something extraordinary. Water is not required for a planet to feel alive. On Earth, water shapes nearly every familiar landscape. Oceans erode coastlines. Rain cuts valleys into stone. Ice grinds mountains into dust. But elsewhere in the cosmos, methane may play the same role. On sufficiently cold worlds, methane becomes a flowing liquid capable of sculpting terrain over millions of years. Entire weather systems may depend on it. There could be methane hurricanes larger than continents, slowly rotating beneath dim starlight. Rivers of liquid hydrocarbons may spill into vast polar seas, while methane snow drifts gently across frozen plains. Along distant coastlines, waves might lap silently against shores made of water ice as hard as granite. Because in those temperatures, ordinary ice becomes rock, and what we think of as gas becomes ocean. Some of these alien worlds may orbit far from their stars, wandering through the cold outer regions of planetary systems where sunlight arrives only as a faint glow. Daytime there would resemble deep twilight on Earth. The stars overhead might shine sharply through dense amber atmospheres, while distant suns barely illuminate the landscape at all. Yet despite the darkness, these places may possess astonishing beauty. Imagine endless black seas reflecting pale orange clouds, rain falling slowly through heavy air, winds whispering across frozen methane dunes, lightning flickering silently within thick hydrocarbon storms. Everything familiar, yet transformed into something dreamlike and strange. Scientists believe some exoplanets may contain oceans vastly larger than anything on Earth. Entire hemispheres covered not in water, but in liquid methane or ethane, stretching beyond the horizon beneath perpetual haze. The temperatures there would be unimaginably cold, cold enough for metals to become brittle, and for complex chemistry to unfold at glacial speed. Time itself might feel slower there. Storms may last for years. Clouds may drift lazily through dense atmospheres. Seasonal changes could take decades or centuries depending on the planet's orbit. And in the stillness of those frozen worlds, chemistry continues quietly beneath the dark. One of the strangest questions scientists now ask is whether life itself could exist inside such alien oceans. Not life as we know it, not oxygen-breathing organisms swimming through water, something entirely different. On Earth, life depends on liquid water because water is an excellent solvent for chemistry. But some researchers wonder whether methane could serve a similar purpose under the right conditions. Could exotic microorganisms exist within hydrocarbon lakes? Could completely alien biochemistry emerge in temperatures so cold that cellular processes move incredibly slowly? Perhaps somewhere in the galaxy, life swims not through oceans of water, but through seas of liquid methane beneath skies permanently wrapped in orange mist. Such creatures would experience reality differently from us. Their chemistry would unfold slowly. Their metabolisms might take hours or days for processes that happen instantly inside living cells on Earth. Even movement could seem dreamlike and gradual beneath the immense cold. It sounds impossible at first, but many things in astronomy once sounded impossible. Planets orbiting dead stars, worlds wandering alone between galaxies, rain made of molten glass, clouds formed from vaporized rock. Again and again, the universe reveals that nature is far more inventive than human imagination. And perhaps somewhere tonight, on a world circling a dim red dwarf star, methane rain is falling softly into a dark, silent sea. There may be beaches there shaped from frozen hydrocarbons, towering cliffs of ice harder than concrete, thick fog drifting above black liquid coastlines beneath a sky where the sun appears only as a faint reddish glow. No birds, no forests, no sound except the slow movement of alien wind, yet strangely peaceful. These worlds remind us how deeply Earth has shaped our understanding of what a planet should be. We instinctively search for blue oceans, white clouds, green landscapes. We imagine habitability through the lens of home. But the galaxy may contain countless forms of beauty beyond those expectations. On methane worlds, weather still tells stories. Rain still falls from clouds. Rivers still search for lower ground. Seasons still change beneath distant stars. The ingredients differ, but the rhythms remain. And somewhere far beyond our solar system, entire coastlines may exist, where waves of liquid natural gas roll endlessly through the dark, beneath skies humanity has never seen. Perhaps future telescopes will one day detect them clearly. We may observe the spectral fingerprints of methane oceans reflecting dim starlight across distant exoplanets. We may watch alien storms form in atmospheres rich with hydrocarbons. We may even map the outlines of vast frozen seas from light years away. For now, these worlds remain mostly hidden. Tiny shadows crossing distant stars, faint signals buried inside starlight. But even from across the galaxy, they whisper something extraordinary. Earth is not the only way a world can exist. There are planets where oceans burn with cold instead of heat. Worlds where rain falls in darkness beneath skies colored bronze and gold. Places where chemistry rewrites the meaning of rivers, seas, clouds, and storms. And somewhere in that endless cosmic night, methane tides may still be rising quietly beneath frozen alien moons, while unfamiliar rain drifts softly into black oceans that have never once seen sunlight. The Milky Way often feels alive with motion. Stars explode in brilliant supernovas. Giant clouds of gas collapse into newborn suns. Black holes consume matter in violent spirals of light. Entire star systems drift endlessly around the galactic center at hundreds of thousands of miles per hour. When we imagine the universe, we usually imagine something restless and dramatic. But not every corner of the galaxy is chaotic. Far beyond the crowded spiral arms and glowing stellar nurseries, there are regions so quiet that almost nothing changes for billions of years. Places where the stars are few, where radiation is weak, where gravity moves gently and slowly through the dark. The quietest places in the Milky Way are not empty. They are simply distant from the noise. Out near the outer edges of the galaxy, far from the crowded core where stars cluster tightly together, the cosmos becomes calmer. The density of stars drops. Supernovas become rare. Close encounters between solar systems happen far less often. A planet living there might orbit peacefully for billions upon billions of years without interruption. No nearby stars disturbing its orbit. No violent bursts of radiation stripping away its atmosphere. No crowded skies blazing with constant stellar light. Just darkness, silence, and time. Imagine standing on a world in one of these remote, galactic regions. Its night sky would look different from ours. Here on Earth, the Milky Way stretches brightly overhead because we live inside one of the galaxy's active spiral arms. Thousands of stars crowd our skies. But farther out, the heavens may appear darker and more sparse. The stars would feel farther apart, more isolated. The glowing band of the Milky Way might fade into a dim mist barely visible across the sky. And yet, there would be beauty in that emptiness, a kind of cosmic stillness. On such worlds, time may unfold differently psychologically, not because clocks move slower, but because change itself becomes rare. Entire continents could remain geologically stable for immense stretches of history. The skies might look nearly identical for millions of years. No nearby supernovas would blaze suddenly into view. No wandering stars would disrupt the darkness. Imagine civilizations evolving beneath skies that barely change across thousands of generations. Their myths would not revolve around chaos or destruction. They would know the universe as something patient and quiet. Perhaps life itself benefits from such calmness. Some scientists believe regions near the crowded galactic center may be too dangerous for stable biological evolution. Radiation levels there are higher. Stellar encounters occur more frequently. Supernovas erupt more often, potentially sterilizing nearby worlds with bursts of energy. But in the quiet outer regions, life may have time. Time to emerge slowly. Time to evolve complexity. Time to survive. Earth itself has benefited from relative stability. Our planet has existed long enough for oceans, ecosystems, and intelligent life to develop because catastrophic cosmic events are uncommon here. We live in a relatively peaceful neighborhood of the galaxy. But there may be places even calmer. Worlds drifting beneath ancient stars that burn slowly for trillions of years. Planets orbiting red dwarfs whose gentle light barely changes across unimaginable spans of time. Entire systems hidden so far from galactic turbulence that they experience the universe almost as a silent background rather than an active force. These quiet regions may contain some of the oldest surviving planetary systems in existence. Stars there may have orbited the Milky Way dozens of times since their formation. Their planets could be older than Earth by billions of years, weathered softly by time rather than violence. Mountains may erode slowly beneath thin alien atmospheres. Frozen oceans may remain undisturbed for epochs longer than human history can comprehend. Nothing rushes there. The galaxy itself seems to breathe more slowly. There is something deeply comforting about imagining such places. Human life often feels fast and loud. Cities glow constantly. Information moves instantly. Every day brings change, noise, uncertainty. Even Earth itself can feel restless beneath storms, earthquakes, and conflict. But somewhere far beyond our skies, entire worlds may exist where silence has lasted almost forever. No war, no engines, no radio signals crossing the dark. Only the faint wind moving across ancient plains beneath distant stars. And perhaps these quiet places are not lonely. Perhaps life has had more than enough time to arise there. Imagine a civilization evolving beneath one of those calm skies. Their history may stretch across hundreds of thousands or even millions of years uninterrupted by cosmic catastrophe. Their stars remain stable. Their planets endure peacefully. They may study the galaxy from afar, watching the brighter inner regions shimmer like distant storms, while their own corner of the cosmos remains still. Would they fear the galaxy's crowded center, the way ancient sailors feared violent seas? Would they see quietness as a form of safety? Or perhaps they would simply take it for granted, never realizing how rare such stability truly is. The universe is often described as violent because dramatic events are easier for us to notice. Explosions shine brightly. Collisions release enormous energy. Chaos captures attention. But silence is harder to see. Stillness rarely announces itself. And yet much of the cosmos may spend billions of years doing almost nothing at all. Stars shine quietly. Planets turn patiently. Frozen moons drift through darkness without disturbance. The quietest places in the galaxy remind us that existence does not always require drama. Sometimes stability itself becomes extraordinary. A world surviving peacefully for 10 billion years may be just as remarkable as a supernova. Perhaps even more so, because calmness is fragile. It depends on balance, distance, luck, and gravity behaving gently enough for worlds to remain untouched across endless time. Somewhere tonight, beyond the bright crowded arms of the Milky Way, a lonely star may be shining softly above an ancient planet no human being will ever see. Oceans may rise and fall there beneath dim light. Thin clouds may drift slowly through silent skies. Mountains may stand untouched for millions of years while the galaxy turns quietly around them. And in that distant stillness, almost nothing changes. The stars continue their slow motion. The darkness remains patient, and the universe waits without hurry beneath skies older than memory itself. Every planet begins as dust, not continents, not oceans, not forests, skies, or mountains, just dust. Tiny grains drifting silently through enormous clouds of gas orbiting newborn stars. At first, these particles are almost weightless, floating gently inside spinning disks of material called protoplanetary disks. From a distance, they appear peaceful, glowing softly beneath the light of young suns. But hidden inside that beauty is violence. Because planets are not born quietly. They are forged through endless collisions. In the beginning, a newborn star ignites within a collapsing cloud of gas. Around it, leftover material spreads outward into a vast rotating disk. Inside that disk, countless particles begin moving together through gravity and motion. Dust grains collide softly at first, sticking together through static forces so tiny they almost seem insignificant. But time changes everything. A grain becomes a pebble. Pebbles become rocks. Rocks become mountains drifting through space. And eventually, gravity awakens. As objects grow larger, their gravitational pull strengthens. Soon they begin attracting more material aggressively, pulling nearby debris inward. Collisions become faster, harder, more destructive. Entire worlds are built through impacts powerful enough to melt stone. Imagine an early planetary system billions of years ago. The sky would not be calm. It would be filled with fire. Gigantic bodies crash together at tens of thousands of miles per hour. Molten rock sprays outward into space. Shock waves ripple through forming atmospheres. Entire surfaces melt into glowing oceans of magma beneath skies, thick with ash and vaporized stone. Young planets are wounded into existence. Earth itself was once like this. Long before oceans or life appeared, our planet was a violent sphere of molten rock repeatedly struck by enormous objects left over from solar system formation. One of those collisions may have changed everything forever. Scientists believe a Mars-sized world called Theia slammed into the early Earth with unimaginable force. The impact was catastrophic. Entire regions of both worlds vaporized instantly. Rock exploded into orbit around Earth. The planet's surface melted completely. And from the debris of that collision, the moon was born. It is strange to realize that even something as peaceful as moonlight began in violence. This process may be unfolding across the galaxy right now. Around distant stars, young worlds are still colliding in darkness. Astronomers have observed enormous disks of dust surrounding infant suns where planets are actively forming. Inside those glowing disks, gravity sculpts matter slowly over millions of years. Giant protoplanets carve gaps into the surrounding material, while spirals of gas swirl around them like cosmic hurricanes. We are witnessing worlds in the act of becoming. Some newborn planets remain so hot from formation that they glow visibly in infrared light. Others continue pulling material inward, growing larger each year. Their atmospheres churn violently. Their orbits shift unpredictably. Nothing is stable yet. Planet formation is messy, chaotic, unfinished. Even after a planet fully forms, the violence often continues. Young solar systems are crowded places, filled with leftover asteroids, comets, and unstable worlds competing gravitationally for space. Some planets are pushed inward toward their stars. Others are thrown completely out of their systems, becoming rogue planets wandering alone through interstellar darkness. Entire worlds can be destroyed before a solar system finally settles into balance. And yet, from all that destruction, something extraordinary eventually emerges. Stability. Oceans cool, atmospheres form, rain begins to fall, volcanoes shape continents, the chaos slowly quiets. A planet that once glowed like a furnace may one day support clouds drifting peacefully through blue skies. There is something deeply beautiful about that transformation. Because every calm world begins in fire, even the gentlest places in the universe were once violent beyond imagination. Some exoplanets we observe today may still be trapped in these early stages. Certain young worlds orbit so close to their stars that their surfaces remain partially molten. Lava rivers may stretch across glowing landscapes, while volcanic eruptions release thick mineral clouds into the atmosphere. Meteor impacts continue raining from the sky as gravity clears debris from the system. On these planets, creation and destruction happen simultaneously. Mountains rise only to be shattered again. New crust forms while older regions melt beneath unbearable heat. Nothing lasts for long, but over millions of years, gravity continues its patient work. That patience is what truly builds planets. Not a single collision, not one dramatic event, but countless interactions unfolding slowly across enormous stretches of time. Gravity gathers dust grain by dust grain, rock by rock, world by world. And eventually, the result becomes something stable enough for oceans, weather, and perhaps even life itself. Sometimes, astronomers detect strange flashes of infrared light around distant stars. These sudden brightenings may be evidence of planetary collisions happening in real time. Somewhere far away tonight, two young worlds may be crashing together beneath clouds of vaporized rock, releasing enough energy to reshape entire systems forever. No one hears those impacts. Space carries no sound. The destruction unfolds in complete silence. A silent birth, a silent catastrophe. And perhaps that is one of the strangest truths about planets. They appear so permanent when viewed from afar. Mountains seem eternal. Oceans feel ancient and unchanging. Worlds themselves appear stable beyond human comprehension. But every planet is the survivor of countless disasters. Every moon carries scars from impacts long forgotten. Every stable orbit was earned through chaos. Even Earth's existence depended on collisions occurring in exactly the right ways. Without ancient impacts delivering water-rich asteroids, our oceans may never have formed. Without the moon forming through collision, Earth's climate may never have stabilized long enough for complex life to emerge. Violence shaped our home, and across the galaxy, the same process repeats endlessly. New stars ignite. Dust gathers. Collisions begin. Worlds emerge slowly from chaos. Some remain barren forever. Some freeze beneath distant suns. Some become gas giants wrapped in endless storms. And perhaps a few eventually grow quiet enough for oceans, forests, and living creatures to appear beneath calm skies. It is comforting in a strange way to know that creation is rarely gentle. The universe does not build beauty carefully and delicately. It builds through pressure, heat, time, and survival. Somewhere tonight, inside glowing disks surrounding young stars, future worlds are forming. Continents not yet cooled, oceans not yet born, mountains not yet risen. Tiny grains of dust are colliding softly in darkness, beginning journeys that may last billions of years. And perhaps one day, on one of those distant worlds, someone will stand beneath an alien sky and look upward, wondering how their planet began, never realizing that long before the calmness of oceans and clouds, their world too was once fire and drifting dust in the violent nursery of the stars. Somewhere tonight, beneath the endless darkness of space, there may already be another Earth turning quietly around a distant star. Not a world of fire or frozen storms, Not a giant planet wrapped in poisonous clouds, but a place with oceans, clouds, rain, mountains, and skies that glow softly at sunset the same way ours do. And somewhere on that distant world, another civilization may be looking up at their stars, wondering if they are alone too. For most of human history, Earth seemed unique. The only known world with oceans, forests, weather, and life. Ancient civilizations imagined the heavens as perfect and unreachable, filled only with wandering lights moving through the dark. Even after telescopes revealed the planets of our own solar system, many scientists still believed that planetary systems might be rare. But over the last few decades, something extraordinary happened. We began discovering planets around other stars. At first, there were only a few. Strange, massive worlds orbiting impossibly close to their suns. Then, dozens appeared. Then hundreds. Then thousands. Now, we know the galaxy is overflowing with planets. Some are larger than Jupiter. Some are smaller than Earth. Some drift alone through interstellar darkness without a star at all. Others orbit dead stars, frozen remnants of suns that exploded billions of years ago. And among all these strange worlds, astronomers continue searching for one quiet possibility: a planet that feels like home. The search for another Earth is not just about finding a rock in space. It is about finding the right balance of conditions. A world with temperatures gentle enough for liquid water, a stable atmosphere, a calm star, time, stability, chemistry, energy. Life, at least the kind we understand, seems to need patience. Earth itself is proof of that. For billions of years, our planet changed slowly. Oceans formed. Volcanoes reshaped continents. Tiny organisms appeared in the seas long before forests or animals existed. Life evolved gradually beneath shifting skies, while asteroids struck, ice ages came and went, and entire species disappeared. And through all of it, Earth remained within a delicate zone around the sun. Not too hot, not too cold. The habitable zone. Somewhere in that narrow region, water can remain liquid on a planet's surface. It is often called the Goldilocks zone because conditions must be balanced with incredible precision. Too close to the star, and oceans evaporate into thick choking atmospheres like Venus. Too far away, and the surface freezes into endless ice. Astronomers now spend enormous amounts of time searching these quiet regions around distant stars. Every time a planet crosses in front of its star, the light dims ever so slightly. By measuring these tiny changes, scientists can estimate the planet's size, orbit, and sometimes even hints of its atmosphere. It is astonishing to realize that entire worlds are discovered through faint flickers of light, traveling across unimaginable distances. One of the most fascinating discoveries came from the Kepler Space Telescope. For years, Kepler stared silently into one small patch of sky, watching more than 150,000 stars at once. Hidden within that sea of light were thousands of planets waiting to be found. Some systems looked nothing like our own. Others looked strangely familiar. Rocky planets appeared within habitable zones around quiet stars. Worlds only slightly larger than Earth. Places where temperatures might allow rain, rivers, clouds, and oceans. Planets like Kepler 442b, Kepler 186f, and TOI 700d became some of the most intriguing worlds ever discovered. We still know very little about them. We cannot see their continents. We cannot hear their winds. We do not know whether their skies are blue, golden, or permanently covered by clouds. But they exist, and that alone changes everything. Imagine standing on one of these distant worlds. Perhaps the gravity feels slightly heavier beneath your feet. The air may carry unfamiliar scents. The sun in the sky could glow orange or deep red instead of yellow. Shadows might stretch differently across the ground. Maybe strange plants sway beneath alien sunlight. Maybe oceans crash quietly against black volcanic shores. Or maybe life there never became intelligent at all. Perhaps simple organisms drift beneath shallow seas while the planet turns silently through space, unnoticed except by distant telescopes on Earth. Some of the most promising worlds orbit red dwarf stars. These stars are smaller and dimmer than the Sun, but they are also incredibly long-lived. While stars like our Sun burn for billions of years, red dwarfs may survive for trillions. That means life around them could have far more time to evolve. But there is a danger. Young red dwarfs are often violent. They release enormous flares of radiation, capable of stripping atmospheres from nearby planets. Entire surfaces could be sterilized repeatedly by bursts of energy. And yet some red dwarfs eventually calm down. They become quiet, stable stars glowing gently for unimaginable stretches of time. Around these peaceful suns, planets may orbit in eternal balance for billions upon billions of years. If life emerges there, it could become far older than anything on Earth. Older civilizations, older ecosystems, older histories. Some planets may already have witnessed more time than humanity can truly comprehend. The search for another Earth is also becoming more sophisticated every year. Scientists are no longer satisfied with simply finding planets. Now they want to study their atmospheres directly. When starlight passes through a planet's atmosphere, molecules leave faint fingerprints in the light spectrum. Oxygen, methane, carbon dioxide, and water vapor all absorb light differently. By studying these patterns carefully, astronomers hope to detect biosignatures, signs of life, not cities, not radio signals, just chemistry that should not exist without living organisms. On Earth, oxygen is constantly replenished by life. Without plants and microorganisms, it would disappear over time. So if astronomers detect large amounts of oxygen on another planet, alongside methane or water vapor, it may hint at biological activity. A breathing world, a living atmosphere. Perhaps right now, somewhere in the galaxy, forests are already growing beneath alien skies. Perhaps rain is falling across distant oceans, while strange creatures move through shallow tides under unfamiliar constellations. Or perhaps countless habitable planets remain silent forever. That possibility is humbling too, because finding another Earth is not only about discovering life, it is also about understanding how rare life may truly be. Every new telescope brings us closer. The James Webb Space Telescope is already analyzing atmospheres of distant worlds with extraordinary precision. Future observatories may eventually capture direct images of Earth-like planets themselves, not blurry gas giants, not distant points of light, actual worlds, tiny blue spheres floating beside distant suns. And when that moment finally arrives, humanity may experience one of the most profound realizations in history. That Earth is not the only place where oceans shine beneath clouds, not the only world where rain falls, not the only place where living things gaze upward in wonder. Until then, we continue searching, quietly, patiently, listening to starlight crossing the galaxy. And maybe somewhere tonight, while Earth turns beneath its familiar sky, another planet is turning too. Another ocean world, another fragile atmosphere, another place waiting in silence for someone to notice it. And perhaps, across the vast darkness between the stars, two worlds are already searching for each other without even knowing it. There are planets so hot that mountains may slowly evaporate into the sky, not melt, not burn, evaporate. On these extreme worlds, the heat is so overwhelming that stone itself can become vapor, rising into the atmosphere like smoke from a fire. Iron may drift through the air as gas. Silicates may condense into clouds of mineral ash. Entire skies may shimmer with metallic particles, carried by supersonic winds beneath suns that blaze endlessly overhead. These are not worlds shaped by water or ice. They are worlds forged by heat. Worlds where the sky itself may be made of metal. For a long time, planets like this seemed impossible. In our own solar system, even Mercury, scorched by the sun, remains relatively calm compared to some of the exoplanets astronomers have now discovered. But the universe turned out to be far stranger than we imagined. Some planets orbit astonishingly close to their stars, so close that a full year may last only a few Earth days, so close that their surfaces absorb unimaginable amounts of radiation every second. On these worlds, temperatures can climb beyond 4,000 degrees Fahrenheit, hot enough to melt iron, hot enough to vaporize rock, hot enough to create atmospheres unlike anything found anywhere on Earth. One famous example is the exoplanet KELT-9b, one of the hottest planets ever discovered. It orbits so near its star that the planet is heated to temperatures hotter than some stars themselves. The atmosphere is constantly bombarded by ultraviolet radiation, powerful enough to tear molecules apart. Nothing there is gentle. The skies may glow with ionized metals. Streams of vaporized iron drift through the upper atmosphere. Day and night barely resemble the cycles we know because many of these planets are tidally locked, always showing the same face toward their star. One side burns endlessly beneath eternal daylight. The other remains trapped in permanent darkness. Between them may lie violent storms unlike anything our imaginations naturally produce. On Earth, weather is built from water. Clouds form from vapor. Rain falls. Winds move gently between regions of pressure and temperature. But on these worlds, weather is made from minerals. Imagine standing beneath a sky filled not with soft white clouds, but with enormous dark formations of vaporized rock. Tiny particles of silicate drift high above the surface like floating ash. The atmosphere glows faint orange from constant heat. Lightning flashes through clouds made not of water droplets, but metallic compounds and molten dust. Rain may fall there too, but not rain as we understand it. Some planets may experience rainfall made of molten glass. Winds moving faster than sound sweep across the atmosphere, carrying tiny shards of superheated minerals sideways through the air. Instead of falling gently downward like rain on Earth, the burning glass may move horizontally around the planet in endless storms. Everything there is violent. Everything there is reshaped by heat. And yet, despite how hostile these planets seem, they obey the same laws of physics as Earth. Gravity still pulls downward. Atmospheres still circulate. Clouds still form. The same processes that create gentle rainstorms over oceans on Earth can create metallic hurricanes around distant stars. The difference is simply temperature. And temperature changes everything. Astronomers first discovered clues about these metallic skies through spectroscopy. When exoplanets pass in front of their stars, tiny portions of starlight filter through their atmospheres before reaching our telescopes. Different elements absorb light in unique ways, leaving behind spectral fingerprints. Through these faint signals, scientists detected sodium, iron, titanium oxide, magnesium, and other strange compounds floating in alien atmospheres. Some planets even appear to have clouds made from vaporized minerals, similar to those found in sand, stone, or gemstones. Imagine clouds made from sapphire dust, drifting across an endless burning horizon. Imagine skies where aluminum oxide condenses high above the planet before falling back toward the inferno below. These discoveries reveal something extraordinary about the universe. Planets are not limited to the kinds of worlds we know. Nature keeps building realities stranger than fiction. Some of these planets may not even survive forever. The heat from their stars is so intense that entire atmospheres are slowly escaping into space. Astronomers have observed giant tails of gas streaming behind certain exoplanets, like glowing comets. These worlds are evaporating. Bit by bit, year after year, the star is consuming them. Rock vapor rises upward. Ultraviolet light tears atoms apart. Gravity weakens its grip. Slowly, silently, the planet begins to disappear into the darkness. and still it continues orbiting. There is something strangely beautiful about that. A world dying slowly beneath impossible sunlight, wrapped in clouds of its own evaporated mountains. Some scientists believe certain ultra-hot planets may have oceans once long ago, before migrating inward toward their stars. In the early chaos of planetary systems, giant worlds can shift positions dramatically. A planet born far from its sun may spiral inward over millions of years until it reaches regions of unbearable heat. If that happened, some of these burning planets may once have been cooler places. Perhaps clouds once floated peacefully above ancient oceans. Perhaps moons circled quietly overhead before the star transformed the planet into a furnace of metal and fire. The universe changes worlds constantly. Nothing remains fixed forever. Even planets can become unrecognizable with enough time. Yet despite their violence, these metallic worlds help scientists understand planetary formation in ways calmer planets cannot. Extreme temperatures reveal chemistry more clearly. Atmospheric layers become easier to study. Winds and heat circulation expose the hidden behavior of alien climates. Every strange planet teaches us something about how worlds evolve. And perhaps that is one of the most astonishing truths hidden within modern astronomy. The universe is not trying to create Earth over and over again. It is experimenting endlessly. For every calm blue planet, there may be thousands of worlds wrapped in methane haze, buried beneath black ice, or glowing beneath metallic skies. Some are crushed by gravity. Some drift alone between stars. Some orbit dead suns. Some burn so fiercely that stone becomes weather. And still they exist, silent, real, turning endlessly through the dark. If you could stand on one of these metallic worlds, the experience would feel almost dreamlike. The horizon might glow red beneath thick, shimmering haze. Lightning could flash through clouds of mineral ash. The ground itself might radiate heat intense enough to soften metal beneath your feet. Above you, iron vapor drifts through the atmosphere like smoke. The sky is no longer blue. The sky has become geology, a furnace made visible. And somewhere far away beyond those burning clouds, tiny and distant, another star may shine softly in the darkness. Around it may orbit cooler planets with rain, forests, oceans, and quiet winds. That contrast is what makes the universe feel so enormous. Within the same galaxy, nature creates frozen ocean worlds buried beneath eternal ice and blazing planets where even mountains cannot remain solid. And between those extremes, countless other realities wait unseen. Some gentle, some terrifying, some so strange that human language barely knows how to describe them. But they are out there tonight. Worlds where the sky itself has turned to metal. Worlds where heat rewrites the meaning of weather. Worlds that remind us the cosmos is not only vast, but wildly imaginative beyond anything we once believed possible. Somewhere in the galaxy tonight, a planet may already be dying, not in a sudden explosion, not in a violent collision, but slowly, almost peacefully, spiraling closer and closer toward the star that created it. With every orbit, gravity pulls a little harder. With every passing year, the planet moves slightly inward. And one day, after millions of years of silent descent, it will finally disappear into the fire. There is something strangely haunting about doomed planets. We often imagine worlds as permanent things, ancient spheres drifting endlessly through space unchanged. But planets are fragile in ways we rarely think about. Stars evolve, orbits shift, gravity never truly rests. And sometimes, a world is born into a system where survival was never possible from the beginning. Astronomers have discovered several exoplanets orbiting dangerously close to their stars. These worlds circle so near that a single year may last only hours or days. They race around their suns at incredible speeds, while enduring temperatures hot enough to melt rock and boil entire atmospheres away. But heat is not their only problem. The real danger is gravity. When a planet orbits extremely close to its star, tidal forces begin to dominate its future. The star's gravity pulls unevenly across the planet, stretching it slightly. That stretching creates friction deep inside the planet's interior, converting orbital energy into heat. Slowly, the orbit changes, tiny amounts at first, almost impossible to notice, but over immense stretches of time, those tiny changes become catastrophic. The planet begins falling inward. Astronomers have actually observed hints of this process happening in real time. Certain exoplanets show orbital periods that are shrinking by fractions of a second over the years. It may sound insignificant, but across millions of years, those fractions accumulate into a fatal drift toward destruction. The clock is already ticking, and the planet cannot escape. One of the most fascinating examples is a world known as WASP 12b, a giant exoplanet orbiting so close to its star that its atmosphere has become stretched into an enormous oval shape. The star's gravity is literally pulling material away from the planet. It is being consumed. Not instantly, but gradually. The planet still circles its star. Winds still move through its atmosphere. Clouds may still drift across its skies. Yet all the while, invisible forces are dragging it closer to the end. There is something deeply cosmic about that image. A planet continuing its normal existence while doom unfolds slowly around it. If life somehow existed on such a world, the changes might happen too gradually to notice at first. Generations could rise and disappear beneath increasingly hotter skies. Oceans might slowly evaporate. Storms would grow more violent. The star would appear larger year after year. The end would not come as a surprise. It would arrive like a slow sunrise. No one could stop. As the planet spirals inward, tidal heating becomes more intense. Volcanoes may erupt continuously across the surface. Entire regions crack open beneath the stress of gravitational forces. The atmosphere thickens with ash, vaporized minerals, and superheated gas. Eventually, the oceans vanish entirely. Clouds burn away. Mountains soften beneath impossible temperatures, and the planet enters its final stage. At a certain distance, gravity becomes overwhelming. The star begins stripping the atmosphere directly into space. Huge streams of gas trail behind the doomed world, like glowing tails on a comet. The planet starts to come apart, bit by bit, atom by atom, until finally, after millions of years of descent, the remaining core crosses the final boundary and disappears into the star itself. For a brief moment, the star may brighten slightly as it absorbs the last remains of the world. Then silence returns. The orbit is empty. Nothing remains except heat and memory. What makes this even more astonishing is that planetary death may be surprisingly common across the universe. Young planetary systems are chaotic places. Giant worlds migrate inward. Gravitational encounters fling planets into strange orbits. Some systems become unstable for billions of years before finally collapsing. Not every planet receives a peaceful future. Some are ejected into interstellar darkness forever. Others crash into neighboring planets, and some slowly descend toward the stars they once orbited safely. Even our own solar system is not perfectly eternal. On unimaginably distant timescales, gravitational interactions between planets can alter orbits in subtle ways. Stability in the cosmos is often temporary. Everything moves, everything evolves, even worlds. Yet there is also beauty in this process. The atoms inside doomed planets do not truly vanish. When a star consumes a planet, the material becomes part of the star itself. Heavy elements mix into stellar atmospheres. Future planets may eventually form from those same materials somewhere else in the galaxy. Destruction becomes recycling. An ending becomes a beginning. The iron in distant worlds may someday help build new moons, new planets, perhaps even life. In a strange way, the universe wastes nothing. Imagine standing on a planet slowly falling into its star. At first, the sky may look beautiful. The sun dominates the horizon, enormous and brilliant. Light pours constantly across the landscape. The air shimmers with heat. Oceans glow beneath endless daylight. But over centuries, subtle changes appear. The star grows larger. The days become hotter. Storms intensify. Tides rise unnaturally high beneath the star's gravitational pull. Eventually, the oceans retreat into steam. Rivers vanish. The ground cracks beneath expanding deserts. The horizon glows red at night from volcanic eruptions triggered deep within the planet's interior. And still the world keeps orbiting. Still gravity continues its patient work. There is no escape, only descent. Some astronomers believe certain planets may survive for billions of years before finally reaching this fate. Others may already be near the end right now. Somewhere tonight, hidden among the stars, entire worlds may be crossing their final orbits. No one there to witness it. No sound in the vacuum. Just a silent spiral inward through the dark. These doomed planets remind us that the universe is not static. Stars are born, planets form, galaxies collide, and worlds disappear constantly across cosmic time. What feels permanent to us is often temporary on larger scales. And yet, temporary things can still be beautiful. Perhaps especially because they are temporary. Earth itself exists within a delicate balance. Our orbit remains stable. Our sun burns calmly. Oceans still move beneath quiet skies. But the cosmos around us is filled with worlds far less fortunate. Planets consumed by gravity. Worlds trapped in fatal orbits. Silent spheres circling slowly toward fire. And maybe there is something oddly comforting about that too. Because even in destruction, the universe remains patient. Nothing rushes. Entire planetary deaths unfold slower than civilizations rise and fall. The cosmos does not hurry toward endings. It drifts, quietly, steadily, like a planet falling toward its star beneath an endless sea of light. And if this journey through the cosmos is helping you relax tonight, consider subscribing before you drift off to sleep. Somewhere far beyond our solar system, there may be a planet where the sun never moves. No sunrise, no sunset, no changing seasons crossing the sky. Just one eternal hemisphere locked beneath endless daylight, while the other remains buried forever in darkness. And between those two extremes, winds may rage endlessly across the surface, circling the planet without ever stopping. These are tidally locked worlds. Planets caught in one of the strangest arrangements the universe can create. On Earth, the planet spins freely beneath the sun. Every 24 hours, day becomes night, and night becomes day. The cycle feels natural because it has always been part of human life. Our climate, biology, sleep, and even our sense of time evolved around that rhythm. But not every world receives such balance. Some planets orbit so close to their stars that gravity gradually slows their rotation over millions of years. Eventually, the planet becomes locked, always showing the same side toward the star, much like the moon always shows the same face to Earth. One side experiences eternal day, the other, eternal night. At first glance, these worlds seem impossible places for life or stability. The day side may become blisteringly hot beneath constant sunlight. Oceans could evaporate into thick clouds. Rocks may glow red beneath endless heat. Meanwhile, the night side may freeze beneath permanent darkness. Temperatures plunge lower and lower without sunlight to warm the surface. Ice spreads across endless plains beneath skies filled with unmoving stars. But the true story of tidally locked planets may lie not in stillness, but in motion. Because while the sunlight remains fixed, the atmosphere does not. The difference in temperature between the burning day side and frozen night side creates immense pressure gradients across the planet. Hot air rises beneath the eternal sun, while cold air sinks into darkness. The atmosphere begins moving constantly, trying to redistribute heat from one hemisphere to the other. The result may be planetary winds unlike anything Earth has ever known. Jet streams wrapping around the entire world, storm systems that never weaken, hurricanes larger than continents spinning endlessly across alien skies. On some tidally locked exoplanets, scientists estimate winds may exceed thousands of miles per hour. Entire atmospheres could roar continuously around the planet in permanent circulation patterns driven by relentless heat. There is no calm season, no quiet weather, only endless motion. Imagine standing near the boundary between day and night on such a world. Astronomers sometimes call this region the Terminator Zone, the thin ring where eternal daylight meets eternal darkness. Here, conditions might actually become surprisingly gentle compared to the violent extremes elsewhere on the planet. The star hangs forever near the horizon, frozen in place. One direction leads toward burning deserts, glowing beneath constant sunlight. The other fades into black frozen plains where ice stretches endlessly beneath unfamiliar constellations. And overhead, powerful winds sweep continuously across the sky, carrying clouds, dust, and storms between the two hemispheres. This twilight region may be one of the most beautiful places imaginable in the cosmos, a world balanced permanently between fire and ice. Some scientists even believe tidally locked planets around quiet red dwarf stars could potentially support life. Since red dwarfs are smaller and cooler than our Sun, their habitable zones exist much closer to the star. Planets within those regions are highly likely to become tidally locked over time. For years, astronomers worried this would make such worlds uninhabitable, but newer climate models suggest otherwise. If the atmosphere is thick enough, winds and oceans may transport heat efficiently around the planet. Instead of one side burning and the other freezing completely, the climate could stabilize into something surprisingly moderate. Clouds may form permanently above the hottest regions, reflecting sunlight back into space and cooling the surface below. Oceans may circulate warmth into the dark hemisphere. Rainstorms could migrate endlessly around the planet beneath colossal atmospheric currents. Life, if it exists there, would evolve beneath conditions unlike anything on Earth. Creatures on the day side might never experience darkness. Organisms on the night side might live beneath frozen skies, illuminated only by stars and auroras. And along the twilight boundary, perhaps entire ecosystems could thrive beneath the eternal glow of a motionless sunset. There is something strangely peaceful about imagining a sky where the sun never changes position. No passing hours, no fading evening light, just one quiet eternal horizon stretching across the world forever. But the atmosphere itself would never rest. The winds become the planet's heartbeat. On some gas giant exoplanets, the storms may grow unimaginably large. Since there are no continents to interrupt atmospheric flow, hurricanes could circle the entire planet continuously for centuries. Lightning flashes through colossal cloud bands while deep below, pressures rise high enough to crush metal. Some storms may migrate slowly between the day and night sides, feeding on constant temperature contrasts. Others remain fixed beneath the substellar point, the exact location where the star hangs directly overhead forever. Astronomers have already detected hints of these violent atmospheres through spectroscopy and thermal mapping. By studying how heat moves across exoplanets, scientists can estimate wind speeds and atmospheric circulation patterns. Even from light years away, we are beginning to sense the weather of alien worlds, and the results are astonishing. Some tidally locked planets may have supersonic winds powerful enough to transport entire clouds of vaporized minerals across the globe. Others may experience permanent thunderstorm systems fueled by endless evaporation beneath eternal daylight. The atmosphere becomes an ocean of motion wrapping endlessly around the planet. It is strange to think that some worlds may never know silence. Earth occasionally experiences calm nights, wind fades, oceans settle. The atmosphere rests for a while beneath the stars, but on tidally locked worlds, the winds may never truly stop. Not for thousands, not for millions, perhaps not for billions of years. The entire planet becomes a machine powered continuously by gravity and starlight. And yet, despite the violence, there is also balance. The storms persist because the system remains stable. Heat flows, air circulates, energy redistributes itself endlessly across the globe. Even chaos can become predictable given enough time. That may be one of the most fascinating truths about the universe. Extreme worlds are not necessarily broken worlds. They simply follow different rhythms. On Earth, we measure life through cycles of day and night. Elsewhere, entire planets may live beneath skies where time feels frozen while the atmosphere races endlessly onward. And somewhere tonight, beneath a distant red sun, there may already be a world where hurricanes have circled continuously for longer than human civilization has existed. A planet where the wind never sleeps, where clouds drift endlessly between fire and darkness, where one side of the world burns beneath eternal noon, while the other waits beneath frozen stars. And between them, in the endless twilight ring, the universe may have found another way for a planet to remain alive. Some moons may be larger than planets, hidden beneath the shadows of enormous gas giants. Far beyond the warmth of familiar suns, giant planets drift through the darkness like silent storms frozen in time. Some are larger than Jupiter. Others glow faintly with leftover heat from their violent births. Around them circle entire families of moons, worlds trapped in endless orbit beneath vast, swirling clouds of gas and lightning. And some of these moons may not be small barren rocks at all. Some could be worlds in their own right. In our own solar system, moons already challenge what we thought planets should look like. Jupiter's moon Ganymede is larger than the planet Mercury. Saturn's moon Titan possesses rivers, lakes, clouds, and rain. Europa hides an ocean beneath cracked ice. Enceladus sprays water into space from beneath its frozen crust. These are only the moons close to home. Now imagine what might exist around giant exoplanets orbiting distant stars. A massive gas giant, many times the size of Jupiter, could easily host moons larger than Earth itself. Entire worlds circling another world. Some may have thick atmospheres, deep oceans, weather systems, mountains, and perhaps even conditions suitable for life. Yet, they remain hidden, difficult to detect beside the overwhelming brightness and gravity of the giants they orbit. From the surface of one of these moons, the sky would feel impossible. The gas giant above would dominate everything. It might stretch across half the heavens, glowing with swirling storms larger than continents. Colored bands of orange, silver, blue, or crimson clouds could move slowly across its enormous face. Lightning might flicker deep within its atmosphere for centuries without stopping. Thin rings of ice and dust could arc across the sky like glowing bridges. And unlike our moon, which gently rises and sets, the giant planet overhead might barely move at all. Some moons become tidally locked to their planets, always showing the same face toward them. That means the gas giant would remain permanently suspended in the sky, enormous and unmoving, a constant presence watching over the landscape below. Imagine walking beneath frozen plains, while a planet hundreds of times larger than Earth hangs silently overhead. Its reflected light could illuminate the surface even during the night. Oceans might shimmer faintly beneath pale blue skies. Ice fields could glow silver under the light of distant stars and the enormous planet above. And somewhere far away, a small sun would drift slowly through the darkness. Some of these moons may orbit within the habitable zones of their systems. Not too hot, not too cold, just warm enough for liquid water to remain stable. Scientists believe moons around giant planets could potentially support life, especially if they possess thick atmospheres or underground oceans warmed by tidal heating. Tidal heating is one of the strangest forms of warmth in the universe. As a moon orbits a massive planet, gravity stretches and squeezes its interior over and over again. Rock bends slightly, ice cracks, friction builds deep below the surface. Over millions of years, this constant flexing generates enormous amounts of heat. Even worlds far from their stars may remain alive inside. Europa, one of Jupiter's moons, may already contain more liquid water than all of Earth's oceans combined, hidden beneath its icy crust. Enceladus sprays warm water vapor into space through giant fractures near its poles. These moons are frozen on the outside, but beneath the ice, entire oceans may drift silently in darkness. Now imagine moons larger than Earth experiencing the same process. Beneath miles of frozen crust, warm oceans could stretch endlessly through the dark. Hydrothermal vents might rise from the seafloor, releasing heat and minerals into black water untouched by sunlight for billions of years. Strange ecosystems could drift in there, illuminated not by stars, but by chemistry and heat rising from the planet's hidden interior. Life may not always need sunlight. Sometimes gravity itself may keep a world alive. The skies of these moons would constantly change depending on their orbit. During some nights, the giant planet might eclipse the star entirely, plunging the surface into sudden darkness. Massive shadows could sweep slowly across oceans and mountains. Temperatures might drop. Winds could shift. Then gradually, light would return as the moon emerged once more from behind the giant world above. Some eclipses could last for hours. Others might last for days. The rhythm of life on such moons would not be guided only by a star, but by the movements of a planet enormous enough to shape the sky itself. And there may be countless forgotten moons drifting through the galaxy right now. When astronomers search for exoplanets, giant worlds are often the easiest to detect. Their gravity tugs strongly on their stars. Their size blocks more starlight. But smaller moons hiding nearby are far more difficult to find. Many may already exist unnoticed within the data we've collected. Entire worlds hidden in plain sight. Scientists have already begun searching for exomoons, moons orbiting planets around distant stars. A few possible candidates have appeared, including giant moons potentially larger than Neptune itself. Though confirmation remains difficult, the possibility changes how we imagine the universe. Because if planets are common, moons may be even more common. And if moons can hold oceans, atmospheres, and warmth, then the number of potentially habitable places in the galaxy grows enormously. There may be worlds where civilizations rise beneath giant ringed planets glowing in the night sky. There may be frozen moons where oceans whisper beneath black ice. There may be volcanic moons lit by constant lightning from the gas giant above. There may be silent forests growing beneath skies dominated by swirling planets so large they seem impossible. And somewhere out there, one of those moons may already be alive. Perhaps beneath clouds of methane rain, or beneath oceans hidden below ancient ice, something stirs quietly in the darkness. Small organisms drifting through warm underground seas. Creatures adapted to endless eclipses and dim reflected light. Life shaped not by Earth-like skies, but by the enormous gravity of giant neighboring worlds. We do not know yet. But the universe keeps suggesting that worlds are more diverse than we ever imagined. Not all homes orbit stars directly. Some may spend their entire existence circling giants in the dark. And perhaps that is part of the beauty of the cosmos. Even in the shadows of enormous planets, hidden beneath rings and storms and frozen skies, entire worlds may quietly endure unnoticed for billions of years, waiting, turning silently beneath alien heavens while the galaxy moves around them like a slow and endless tide. In crowded stellar nurseries filled with thousands of suns, entire worlds are quietly taking shape. There are places in the galaxy where darkness barely exists. not because the stars are brighter there, but because there are simply so many of them. Imagine standing beneath a sky where thousands of suns burn at once, some blue and blinding, others red and faint. Young stars wrapped in glowing clouds of gas drift beside older suns, already surrounded by newborn planets. Light spills across the cosmos from every direction, turning the darkness silver and gold. These are star clusters, the crowded nurseries where stars are born together. For a very long time, astronomers believed these regions might be too chaotic for planets to survive. The gravity of nearby stars constantly pulls at young solar systems. Radiation floods the surrounding gas clouds. Stellar winds crash through space at incredible speeds. Supernovas may erupt nearby, sending shockwaves through the cluster. It seemed impossible that delicate planets could form in such violent places. And yet, the universe proved otherwise. Hidden inside these crowded stellar cities, entire worlds are quietly taking shape. Within enormous clouds of gas and dust, gravity begins its slow, invisible work. Tiny particles drift together. Dust grains collide and stick. Over time, those grains become pebbles. Pebbles become rocks. Rocks gather into worlds, all while thousands of neighboring stars blaze around them. Some planetary systems inside star clusters may form much faster than our own solar system did. Young stars pull material into spinning disks that glow softly in infrared light. Inside those disks, planets emerge almost immediately after the birth of their stars. In cosmic terms, it happens in the blink of an eye. A newborn star ignites, and already, worlds begin to appear around it. The skies on these planets would feel unlike anything imaginable on Earth. Night might never become fully dark. Distant suns could crowd the heavens in every direction, some larger and brighter than our own moon, others glowing faintly in endless layers across the sky. Entire constellations would shift rapidly as nearby stars moved through the dense cluster together. On some worlds, the horizon may never stop glowing. Clouds could drift beneath skies filled with countless points of light. Oceans might reflect dozens of stars at once, turning the surface into a trembling sea of silver fire. Mountains could cast shadows beneath multiple suns, rising and setting at different times. And somewhere in the distance, enormous pillars of glowing gas would stretch across the heavens. Because stellar nurseries are not quiet places, they are alive with creation. The Orion Nebula, one of the most famous stellar nurseries near Earth, already contains thousands of young stars forming inside vast clouds of illuminated hydrogen gas. Hidden within those clouds are protoplanetary disks, swirling structures of dust and gas where new planets are being born right now. We are literally watching worlds form in real time. Some of those planets may never survive. In crowded star clusters, gravity becomes unpredictable. Nearby stars can pass close enough to disrupt planetary orbits. Giant planets may be thrown outward into deep space. Smaller worlds could collide. Entire systems might become unstable over millions of years. Some planets are likely ejected completely from their stars, becoming rogue worlds drifting alone through interstellar darkness. Others remain, and those survivors may become some of the oldest worlds in the galaxy. Star clusters are strange places because stars born together often share the same age. Entire generations of suns ignite from the same collapsing cloud. That means planets inside these systems may also share ancient histories, all beginning together beneath the same glowing nursery. Some clusters are only a few million years old. Others have existed for billions. Globular clusters, for example, are ancient spherical gatherings of stars orbiting the outer regions of galaxies. Some contain hundreds of thousands of stars packed tightly together. Many formed when the universe itself was still young. Imagine planets orbiting there, worlds older than Earth by billions of years, ancient skies illuminated by dense rivers of starlight. Civilizations, if they ever existed, may have watched entirely different versions of the galaxy unfold across cosmic time. The closeness of stars inside these clusters changes something else too. Travel. In our region of the Milky Way, the nearest star is over 4 light-years away. But inside dense clusters, neighboring stars may lie far closer together. A civilization living on a planet there might look into the sky and see nearby suns bright enough to study in extraordinary detail. Interstellar travel between neighboring systems could become far easier. Entire cultures might grow up knowing that other stars are not distant, unreachable points, but nearby destinations glowing just beyond the darkness. The sky itself would constantly remind them that they are not alone. And yet, star clusters can also be dangerous. Young, massive stars release enormous bursts of ultraviolet radiation capable of stripping atmospheres from nearby planets. Supernova explosions may erupt without warning, flooding surrounding systems with lethal energy. Gravitational encounters can destabilize entire solar systems over time. Planetary life inside clusters may live on the edge between creation and destruction. But perhaps that balance is what makes these places so extraordinary. Because even in chaos, the universe keeps building worlds, again and again. No matter how crowded the stars become, no matter how violent the environment appears, gravity continues its patient work. Dust gathers, rocks collide, planets emerge. The universe seems determined to create worlds wherever it can. And perhaps somewhere inside one of these crowded stellar nurseries, life has already begun. Maybe beneath skies filled with thousands of suns, oceans move quietly across the surface of a distant planet. Maybe strange forests grow beneath glowing nebula clouds. Maybe civilizations rise while enormous star clusters slowly orbit the galaxy together through deep cosmic time. Or perhaps these worlds remain silent, young, still cooling beneath crowded skies, waiting for their stories to unfold. There is something strangely beautiful about that thought, that even in the busiest regions of the cosmos, hidden among light and gravity and endless motion, entire planets are quietly being born, small worlds forming beneath giant skies, tiny islands of rock and ocean surrounded by thousands of blazing suns. And while we sleep beneath the calm darkness of Earth's familiar sky, somewhere far away inside a glowing cluster of newborn stars, another world may be opening its skies for the very first time. Some oceans across the galaxy may have watched their suns slowly fade into darkness over millions of years. There are worlds in the universe where the end of daylight does not happen suddenly. No explosion, no instant catastrophe, just a slow fading, a gradual dimming of the sky so gentle that entire oceans may not realize their sun is dying until the warmth is almost gone. Every star changes with time. Even the quietest suns slowly evolve, burning through the fuel hidden deep within their cores. For billions of years, stars shine steadily, filling nearby planets with light and warmth. Oceans move beneath their skies, winds circle continents, clouds drift through familiar days and nights. But eventually, every sun begins to change. And somewhere across the galaxy, there may be oceans witnessing the final light of their stars right now. Imagine standing beside a shoreline on a distant world orbiting an aging sun. The sea stretches endlessly beneath pale skies. Waves roll slowly across dark sand. Above the horizon hangs a star older than Earth's entire history, swollen and deep orange with age. For millions of years, its light has been growing softer and redder. Seasons have shifted, temperatures have slowly fallen. The sky itself has changed color. But to the creatures living there, the transformation may feel almost invisible. Because stars die slowly. Far more slowly than civilizations rise and disappear. On Earth, the sun will eventually expand into a red giant billions of years from now. As it grows, the inner planets will become unrecognizable. Oceans may boil away. Atmospheres may vanish. The familiar blue sky of Earth will disappear beneath a brighter and hotter sun. But farther away in the solar system, icy moons and frozen worlds may briefly awaken beneath the changing light. Places once buried in darkness could experience temporary oceans for the first time. The death of a star does not always bring immediate silence. Sometimes it reshapes entire worlds. Across the galaxy, countless alien oceans may already exist around stars entering the final stages of their lives. Some suns grow larger and cooler over time, bathing nearby planets in deep amber light. The oceans beneath those skies may glow copper beneath endless sunsets. Clouds could burn orange and crimson for centuries. The star above would look enormous, beautiful, and quietly dying. Some planets may spend billions of years frozen far from their stars, only to thaw temporarily when the star expands late in life. Entire oceans may suddenly emerge from beneath ancient ice. Seas that remained locked in darkness since the birth of the system may finally melt beneath the last warmth of an aging sun. For a brief cosmic moment, frozen worlds may bloom. Water flows, clouds form, rain begins to fall, and then eventually the light fades again. There is something haunting about that idea, that some oceans may exist only during the final chapters of a dying star, a temporary sea appearing just before darkness returns forever. White dwarf stars tell another part of this story. When smaller stars finally exhaust their fuel, they collapse into dense glowing remnants called white dwarfs. These stellar cores no longer produce energy through fusion, yet they remain hot for billions of years, slowly cooling in silence. Around some of these dead stars, planets may survive. Oceans may still exist there for a time beneath dim, fading light. The sky above such worlds would feel strange beyond imagination. The star would no longer blaze brightly across the heavens. Instead, it would appear as a small white ember, glowing quietly in eternal darkness. Daylight would resemble twilight. Shadows would remain soft and pale across the surface. The oceans beneath that fading star may move more slowly. Winds weaken. Ice expands toward the equator. Temperatures fall century after century. And still the tides continue. Still the waves reach the shore, as though the planet itself refuses to let go of the light. Some alien oceans may have existed longer than Earth's entire history. On ancient exoplanets orbiting long-lived red dwarf stars, seas may have remained stable for tens or even hundreds of billions of years. These stars burn fuel so slowly that they can survive far longer than our sun ever will. Worlds orbiting them may experience almost unimaginable stretches of time beneath calm red skies. If life emerged there, entire evolutionary histories may have unfolded beneath fading crimson sunlight. Civilizations could rise beside black oceans, reflecting dark red stars. Creatures may evolve beneath skies where sunset colors never change. And eventually, even those ancient suns will begin to cool. Not violently, not suddenly, just slowly enough that oceans may spend millions of years watching the light disappear. Perhaps that is one of the saddest and most beautiful things in the cosmos. Not destruction, but fading. The slow, quiet ending of warmth itself. And yet, even during those endings, oceans may continue to whisper beneath alien skies. Storms may still cross the water. Clouds may still gather at dusk. Rain may still fall softly into darkening seas. The universe rarely rushes. Even death often arrives gently. There may also be worlds where underground oceans survive long after surface light is gone entirely. Beneath thick layers of ice, hidden seas warmed by tidal forces or radioactive heat may continue moving in darkness for billions of years after their stars have faded. Above them, frozen landscapes remain silent beneath dead skies. But deep below, warm currents still flow through black water untouched by sunlight. Life, if it exists there, may never know the stars are gone. And perhaps somewhere across the galaxy, an ocean is seeing its final sunrise right now. a distant sea beneath dim orange clouds, waves moving slowly toward empty shores, a dying star trembling near the horizon as its ancient light weakens year after year. No witnesses, no voices, only the quiet rhythm of water beneath a fading sky. It is strange to think that oceans themselves may remember the history of stars. They reflect the first light of newborn suns. They endure through stable ages of warmth. And sometimes they remain until the very last glow disappears into darkness. The universe is filled not only with planets and stars, but with endings. Beautiful endings, slow endings, silent endings stretching across millions of years. And somewhere beyond the reach of our telescopes, beneath skies we will never see, alien oceans may still be waiting beneath the final light of dying suns, reflecting the last colors of worlds slowly drifting into night. Across the universe, weather does not always mean rain and clouds. Sometimes it means iron snow, diamond storms, or burning skies. On Earth, weather feels familiar. Rain falls softly across oceans and forests. Snow drifts silently through winter air. Thunderstorms gather on distant horizons before lightning briefly turns the night white. Winds move through valleys and across open seas, carrying the scent of water and stone. But beyond our world, weather becomes something stranger, something almost impossible, because the universe builds atmospheres from whatever materials exist, and on distant planets, those materials are often far more exotic than anything found beneath Earth's skies. There are worlds where clouds are made of vaporized rock, worlds where metal condenses into rain, worlds where storms glow with molten heat beneath black alien suns. And somewhere in the galaxy right now, impossible weather is unfolding across skies no human being will ever touch. Some exoplanets orbit so close to their stars that their surfaces become hotter than molten lava. On these worlds, temperatures rise high enough to vaporize minerals normally locked inside mountains and stone. Silicates, iron, magnesium, and other rocky materials rise into the atmosphere as gas. The sky itself becomes made of rock. High above the surface, those vaporized minerals cool and condense into clouds. Winds then carry them across the planet at supersonic speeds. Eventually, tiny particles begin to fall back down toward the surface like strange alien rain. Not water, not ice, but burning droplets of molten stone. On some worlds, scientists believe the rain may consist of liquid glass carried sideways by violent winds. One famous exoplanet, HD 189733b, experiences winds so powerful they can hurl superheated silicate particles through the atmosphere at thousands of miles per hour. Imagine standing there. The sky above glows deep cobalt blue, beautiful from a distance, but the air itself is deadly. Shards of molten glass scream sideways through the atmosphere, faster than sound, carving endlessly through burning clouds beneath the light of a nearby star. Even the storms become unfamiliar. On giant gas planets larger than Jupiter, hurricanes may grow larger than entire planets. Endless storms swirl through atmospheres thousands of miles deep. Lightning flashes continuously beneath layers of ammonia, methane, and hydrogen clouds. Some tempests may survive for centuries without stopping. Jupiter's Great Red Spot has already lasted for hundreds of years, but elsewhere in the galaxy, storms may endure for millions. Some exoplanets are tidally locked, meaning one side always faces the star while the other remains trapped in endless darkness. On these worlds, the difference in temperature between day and night becomes extreme beyond imagination. The day side burns beneath eternal sunlight. The night side freezes beneath endless black skies. Between them, winds race continuously around the planet, attempting to redistribute heat. Massive jet streams roar through the atmosphere at incredible speeds. Entire weather systems circle the globe forever without rest. The sky never calms. The storms never end. and the horizon itself may glow with constant lightning. There may also be worlds where diamonds fall from the sky. Deep within the atmospheres of certain giant planets, pressure becomes unimaginably intense. Carbon atoms may compress into crystal structures, forming diamonds high above the planet's hidden interior. Some scientists believe those diamonds could slowly descend through the atmosphere like glittering rain before sinking into vast oceans of liquid carbon far below. Entire storms made of gemstones, invisible from space, silent beneath layers of thick cloud. On colder worlds, weather becomes no less strange. Far from their stars, temperatures fall low enough for gases like methane and ammonia to freeze into snow. Ice clouds drift through dim alien skies, while pale crystals gather across frozen landscapes. Snowfall may appear blue, orange, or green depending on the chemistry of the atmosphere and the light of the local star. Methane rain may fall into black hydrocarbon seas. Nitrogen frost may coat mountains beneath faint red sunlight. Ammonia snow could drift across frozen plains untouched for billions of years. Titan, one of Saturn's moons, already gives us a glimpse of this alien climate. Rivers of liquid methane flow across its surface. Clouds gather, rain falls, lakes shimmer beneath orange skies. It is weather, just not weather built for humans, and perhaps that is the most fascinating part. The laws shaping alien weather are often the same laws shaping Earth. Heat rises, pressure shifts, winds form, clouds condense, storms grow. Only the ingredients change, and when the ingredients change, entire worlds become unrecognizable. Some exoplanets may possess skies permanently hidden beneath dust storms that last for centuries. Winds lift fine mineral particles into the atmosphere until the sun itself becomes little more than a faint glow behind endless haze. Entire landscapes disappear beneath drifting clouds of red or black dust. Other planets may reflect enormous amounts of light because of bright metallic clouds high in their atmospheres. Their skies might shimmer silver beneath distant suns. Some worlds may appear brighter than Venus from across interstellar space. And then there are the planets orbiting violent stars. Young red dwarfs often release massive stellar flares, capable of flooding nearby planets with radiation. Auroras may stretch continuously across the skies of those worlds, forming glowing oceans of green, violet, and blue light that never fully disappear. Entire hemispheres may shine electrically through the night. The weather there is shaped not only by air and temperature, but by magnetism itself. Some planets may even experience atmospheric collapse. If temperatures drop too low, gases freeze directly onto the surface. Atmospheres slowly disappear into oceans of solid nitrogen or carbon dioxide ice. The sky itself falls to the ground and becomes part of the landscape. Imagine standing on a world where the air has frozen, where silence stretches endlessly beneath a black sky filled with unmoving stars. The universe keeps reminding us that weather is not a single thing. It is simply the movement of matter beneath gravity and light. And across billions of planets, matter moves in ways both terrifying and beautiful. There may be worlds where iron snow drifts quietly through crimson skies. Worlds where boiling oceans release clouds of stone. Worlds where lightning flashes endlessly through black methane storms. Worlds where the air itself burns. And perhaps somewhere out there, beneath one of those impossible skies, life has learned to survive conditions we can barely imagine. Creatures drifting through methane rain. Organisms floating high inside warm gas giant atmospheres. Life hidden beneath frozen crusts while alien storms rage overhead. We do not know yet, but every new exoplanet discovered expands the boundaries of what a world can be. The universe is not content with simple blue skies and gentle rain. It experiments endlessly, creating climates stranger than dreams. And while Earth sleeps tonight beneath familiar clouds and quiet winds, Somewhere far away, another planet may be turning slowly beneath burning storms of glass and metal, carrying impossible weather through the endless dark between the stars. Somewhere beyond human sight, a distant planet may be turning beneath clouds, oceans, and the quiet glow of another sun. Right now, while Earth drifts through the darkness of space, countless other worlds are doing the same. Some are frozen beneath endless night. Some burn beneath violent stars. Some wander alone between galaxies of light. But somewhere among them, there may be a planet so familiar that, from far away, it would look almost like home. Not identical, not another Earth copied perfectly into the cosmos, but a world where oceans move beneath winds, where clouds gather above mountains, where rain falls softly onto stone beneath an alien sky. For most of human history, we believed our world might be unique. The stars looked distant and unreachable, scattered like cold lights across a silent void. And because we could not see the planets around them, it was easy to imagine that Earth stood alone. But now, we know better. Over the last few decades, astronomers have discovered thousands of exoplanets orbiting distant stars. Some are enormous gas giants larger than Jupiter. Others are scorched lava worlds where rock melts beneath eternal daylight. Some drift freely through space with no star at all. And among those strange and beautiful discoveries, we have also found something quieter: small rocky planets. Worlds orbiting inside gentle habitable zones where temperatures may allow liquid water to exist. Planets where dawn and night may rise and fall beneath calm skies for billions of years. The universe, it turns out, may be filled with places where life could begin. One of the most fascinating things about these distant worlds is how ordinary some of them appear. After all the chaos of exploding stars, black holes, radiation storms, and frozen darkness, we still continue finding planets that resemble something familiar: a rocky surface, an atmosphere, a stable orbit, a star that burns slowly and quietly for unimaginable lengths of time. Some of these planets orbit red dwarf stars, smaller and dimmer than our sun. Others circle stars much like it, glowing with steady yellow light. A few exist in systems where multiple planets move together in delicate gravitational harmony, almost like miniature versions of our own solar system. And every time astronomers detect one of these worlds, a strange feeling follows. Not certainty, not proof, but possibility. Because once a planet has the right temperature, the right chemistry, and enough time, imagination begins to take over. Could oceans exist there? Could storms move across distant continents? Could something alive be breathing beneath those clouds right now? We do not know. And perhaps that uncertainty is part of what makes the search so beautiful. The galaxy is unimaginably large. The Milky Way alone may contain hundreds of billions of stars, and most of those stars likely host planets of their own. Some systems may contain only frozen wastelands or violent gas giants. Others may hold quiet, rocky worlds turning unnoticed in the dark, even if only a tiny fraction are suitable for life. The number of possibilities becomes enormous. There may already be civilizations beneath distant skies. There may be forests growing beneath blue stars. There may be oceans where alien rain falls into black water under moons we have never seen. Or there may simply be silence. Ancient landscapes untouched for billions of years, still beautiful, still waiting. Sometimes it is comforting to remember that Earth itself once looked lifeless too. Long before humans existed, our planet was a hostile place, filled with volcanic oceans, toxic skies, and violent impacts from space. Life emerged slowly, quietly, almost invisibly. Tiny organisms drifted through ancient seas for millions upon millions of years before anything complex appeared. If life can rise slowly from chemistry here, perhaps it can happen elsewhere too. Maybe on a rocky planet orbiting a quiet red dwarf. Maybe beneath the frozen crust of a hidden ocean world. Maybe under clouds glowing orange beneath a thicker atmosphere. The universe has had plenty of time to experiment, and time is one thing the cosmos possesses in abundance. Some stars live for trillions of years. Entire planetary systems may remain stable long after Earth itself is gone. Somewhere out there, a world may already exist that is older than our civilization by incomprehensible amounts of time. An ancient Earth-like planet beneath ancient skies. Perhaps life there had time to evolve far beyond anything we can imagine. Or perhaps simple oceans still wait patiently in silence beneath drifting clouds. The search for another Earth is not really just about finding a planet. It is about searching for connection. For centuries, humanity looked into the night sky and wondered whether the darkness was empty. Every telescope we build is part of the same question. Every distant spectrum of light carries the possibility of an answer. Scientists now study exoplanet atmospheres by watching starlight pass through them. Tiny fingerprints hidden in that light can reveal the presence of water vapor, methane, oxygen, or carbon dioxide. These clues are delicate and difficult to detect, but with each passing year, our instruments grow more powerful. Future telescopes may one day photograph Earth-like planets directly, not as blurry dots, but as visible worlds. We may see oceans reflecting sunlight. We may detect weather systems drifting across continents. We may even discover chemical signs that suggest biology is changing the atmosphere itself. And if that day comes, it will quietly transform humanity forever. Because the moment we confirm another living world, the universe will no longer feel empty in the same way again. But even now, before that discovery arrives, there is something deeply calming about knowing how many worlds already exist. The night sky is no longer just stars, it is planets. Countless planets, frozen worlds, ocean worlds, silent deserts, storm-filled giants, lonely wanderers drifting between suns, and somewhere among them, perhaps another Earth. A place where oceans move beneath clouds at this very moment. A place where rain taps softly against alien shores. A place where another species might look upward into its own night sky and wonder if they are alone too. Maybe they will never know about us. Maybe we will never know about them. And yet both worlds continue turning quietly through the same galaxy together. There is something peaceful in that thought, that the universe is not only vast and cold, but full of hidden places waiting patiently in the dark. Worlds with stories still unfolding. Worlds we have not yet reached. Worlds that remind us existence itself may be far richer and stranger than we ever imagined. And maybe that is why exoplanets capture our imagination so deeply. Because every distant world represents possibility. Not certainty, not answers, but possibility. The possibility that life is not rare. The possibility that Earth is part of something much larger. The possibility that somewhere far away, beneath another sky, another ocean is listening to the quiet rhythm of another world. And maybe, while you rest tonight beneath the stars of Earth, another world is resting too, waiting quietly in the dark for someone, someday, to finally find it.